Thank you very much, Randy. Thank you for having me here. Thank you. Again, my name is Jung Hahn. I'm a professor at NUS School of Computing, and I'm the head of the Information Systems and Analytics Department since about 2.5 years ago. So I'm ending my term. I hope they don't ask me to continue, but it's fairly likely that they will ask me to continue. It's a great honor to be the head, but it's also a lot of work, a lot of work. So prefer not to work that much. Anyway, so I'm very glad to be here. I was asked to present on this topic of big data and data analytics. I presume a lot of you have already heard the term big data, data analytics, and so I might bore you with a bit of background information about what it is, or how we do it and things like that. But please bear with me. I'm going to try to cover the basics so that the actual domain of data analytics and big data is not that different from what companies have been doing thus far. It's what we see nowadays, and what I would try to emphasize in this presentation, in this discussion today, is really how do we go forward to the next version, or the next, the 2.0 of big data analytics, in really creating value in products and services that can be had if we have a more open-minded view about how to use data and how to use analytics as a source of competitive advantage for firms. So so Randip gave a brief background about my life. This only starts my academic life from my undergraduate, my master's. I did it in Korea at Yonsei University. Then I went on to do a PhD at the University of Minnesota. For about 9 years, I've been a professor in the U.S. at Purdue University, and I was also a visiting professor for 2 years at Carnegie Mellon University. And since 2012, I've been at the National University of Singapore at the School of Computing. I've done, among others, I've done some industry collaborations with online startups companies like SimonDelivers.com, some large companies like Samsung, mainly Samsung SDS, which is the IT services arm of Samsung. We're working on some projects on agile software development with Standard Chartered. We're collaborating on fintech and blockchain with IBM research. And recently, I've also been engaged in research with Dentsu Aegis Network, which is a online marketing, online advertising network, a DSP in that space, and that's been very exciting. So this is a brief background about myself. I've been doing the core of my research has been in looking at interesting, impossible phenomena in the world, such as stuff that never should happen but happen, and it's wonderful. So things like open source software development. It has all of the ingredients of being an impossible, like a very utopian view of how things should work. It should never have worked, but somehow it's working. So I'm really interested in looking at non-traditional forms of organizing and organizations, and looking at them from the perspective of using data analytics as a methodology or as a tool to understand these systems. So I've been looking at how people, or how software developers actually collaborate over the internet, over communication networks to actually get software up and running, how teams form within these communities, looking at data from these open source platforms such as SourceForge, GitHub. I've also been looking at software development companies, how their productivity increases, using their internal HR kind of data on who participated in what project was successful, what project was late, what are the, and really trying to get a sense of understanding internal as well as big data to understand phenomena in open innovation kinds of context. So that's a bit of my background. And I'm going to, so the topic of today is big data. And it's a nice term because it sounds good. Big data. It has a nice kind of connotation. It has a nice ring to it. Actually, when I did my PhD in 2003, I was actually working on a project that was, if we look at the project today, we would categorize it as big data, but at the time we didn't have the word big data. And so my dissertation wasn't really in the area of big data, but it was doing big data. I was actually for the company, the SimonDelivers.com on the left, which is an online grocery delivery company, a startup in Minneapolis at the time. We were actually analyzing the web server's logs to understand consumers' purchasing journey. So they log in, they come in, they browse through products, they put them in their carts, and then they check out and they get the groceries delivered to their homes. And so we were analyzing the web server logs to understand the customers' purchase trajectories to identify which areas of the website are actually producing inefficiencies that would cause customers to abandon their shopping carts, to actually purchase. So looking at click-throughs, purchase, transactions, things like that, and really understanding from the data that we can observe in the web server logs, visualizing what's actually happening to get a better sense of what's driving the business for this company. So if you're a physical retailer, you have a store, and you have companies, you have customers coming in, and nowadays we do have this technology, but before we could observe, the salespeople could observe people coming into your store. They know which area of the store people go to, which path people follow, and that's why we always have the milk at the very end corner of the supermarkets, because they want you to. People usually come in just to buy milk, especially in the U.S. But if you have the milk at the very front entrance of the store, people will come in, never explore the store, and just check out and go home. But if you have the milk at the very end, it has other nice properties, such as you can have the refrigerators in the end. It's much cheaper to have it that way for logistical purposes. But you make the customers actually walk through the whole store, and you can have additional impulse purchases and whatnot. And so we're actually looking at, what's actually, so in these physical stores, you can actually observe what people are doing, and the astute manager or the salesperson can observe what's happening and make recommendations about, we should place this product here, there, and increase sales. But nowadays we have new technologies such as video cameras that can track people, and we can trace the path, we can have a complete history. So it's much more fact-based and data-driven approach to doing that. For online companies, this is a little more difficult because we don't have physical stores and we don't really observe what people do, except through these server logs, which are very, it's massively complicated data, but through the cleaning and interpretation of that data, we can actually recreate the customer's actual traversal path in that virtual store to really understand why people are going, in different areas of the store, how people are searching for products, whether or not they're using the recommendation engines, for the products that were recommended, so things like that. So I was doing my research on in a big data area without the term big data, and so I was unfortunate to not have coined the term myself, which would have made me extremely famous. But anyway. Kudos to the person who did. Anyway, so what is data analytics? And again, as I mentioned earlier, it's not much different. So big data analytics is not much different from data analytics. If you think about the term data analytics, we've had it for a long time. I'm going to explain kind of the historical background of this. So the data analytics is simply the process of examining data sets in order to draw conclusions. So you analyze the data sets to draw conclusions about the information they contain. A very simple, crude definition. Okay? Now we're going to put in big in there. Okay? So the only thing that changed here is we put big data analytics. So big data analytics is the process of examining large and varied data sets. Here there's two new terms, large and varied. Very important terms. Large creates technical difficulties. Large creates technical difficulties. Varied also creates technical difficulties in a different way. But large creates a technical difficulty in the sense that it's very difficult. If you truly consider big data, it's almost impossible to analyze it within one machine. Okay, so we have to have new technologies such as the cloud, Hadoop, and things like that for processing, storing, and managing the data. And this part I'm not going to cover in much detail because the technologists and companies will come up with new solutions that will make it transparent to the user, to the analyst who are ourselves. Okay, so the analyst, from our point of view, will have the tools such that even though the actual data resides in network area storages or in clouds, the actual analysis can be done. It takes a little longer, but it actually can be done as if you were doing it on your own laptop or your own PC. Okay, so that part I'm not going to touch. Varied creates a lot of additional difficulties and challenges, technical, because these require additional, different ways of understanding data. Okay, I'm going to explain this in a little more detail later on, but previously we had very structured data. Now we have a lot of unstructured data. Analyzing unstructured data is very, very difficult. We're getting much, much better at this nowadays with a lot of interest in artificial intelligence, a lot of interest in different techniques in artificial intelligence, but it's still extremely difficult to analyze the varied data. Now, when we talk about big data, this is from IBM, there's 4 V's of big data, okay? That's different from just regular data. So we have the volume, this is the large data. So the data at rest, there's a lot of it, and so it creates a lot of these technical difficulties about how to store, how to transform, how to clean. All these things come in there. The second is velocity. Now the rate at which data comes in is now extremely fast. Okay, it's going to get more and more fast, very, very soon. Okay, now think about we have when we get into things like Internet of Things, and we have sensors that provide real-time data on different metrics, such as water, pollution, water quality. We have sensor data, we have video data from CCTVs on traffic congestion. We have, or pedestrian kind of congestion, or how many people are walking on these streets. All these data is coming in real time. And so if you're a data analyst and you have all the data prepared in a nice Excel spreadsheet or a relational database table, and it's given to you, analyzing it is really, really easy, right? Now think about the streaming data that's coming through, like from IoT sensors. You need to have systems in place or algorithms in place that can analyze the data in real time without it being stored. If you have everything stored and you're analyzing 3 years worth of data, it's not easy, but it's not that difficult. But if you have streaming data coming in where you can't store the data, because if you start storing this data, the world is too small to be able to store. Every place will become a data center. Every house has to have a data center in the basement. Okay, it's impossible to store all of the data. So a lot of the data is created, but it's created, it's captured kind of instantaneously, in the sense that we have it at one point in time when it is captured, but then it vanishes forever. A lot of the data is like that. We cannot store the data indefinitely. A lot of the data, especially from Internet of Things kind of devices, sensors, cannot be stored indefinitely. And so we have to deal with the situation. Okay? That's velocity. Now we have variety. Okay? A variety is the different kinds of data. As I mentioned earlier, before we had structured data, now we have a lot of unstructured data. Think about social media data. Okay, I think, is Facebook popular in Thailand? Very popular. Okay, Facebook is very popular. So you all use Facebook, you all see your friends posting comments. People don't post very structured things. Okay, you could structure things such as, these are likes on different kinds of brands. So we can create databases or data models that capture whatever structure we impose on the content that's been shared. But a lot of the times, the content, the data that we see are unstructured data. It's text. It's a sentence that a friend posts about his visit to the Novotel Bangkok in Siam Square. Okay. The staff was very friendly. Okay. Now, if I put a post and say Novotel Bangkok Siam Square staff was very friendly, you could use that if you're a staff member, if you're a manager at Novotel Bangkok in Siam Square, you could use that, and if you have a lot of people posting about, then you can grasp the public's kind of perception about the service quality. Now, if I say Novotel's staff was very friendly, what is your interpretation of that statement? You think it's a positive statement?
Positive
It
statement.
could be construed. If you take it literally, it could be construed as a positive statement. But if I say it like, Novotel staff was very friendly, very friendly. Is that a positive sentiment or is that a sarcastic negative sentiment? It could be construed as a negative sentiment. But on the Facebook page, on the Facebook post, it would be exactly the same. It's just text, right? And deciphering that is extremely hard. Understanding sarcasm, understanding the intent of the person is extremely hard. And so the very variety of data, especially when it comes to unstructured text, where people don't speak in full sentences with correct grammar, they don't speak with, they speak with the shorthand, BRB for be right back. I don't know, my daughter is 17 years old. I cannot understand the chat she has with her friends because everything's in acronyms and I have no idea what she's saying. Some of them I try to interpret, could be very inappropriate, but I ask her and she says, oh, it's nothing. I don't know what she's saying. Okay, so that's variety. There's a lot of new unstructured data that creates immense challenges, but also immense value, opportunity for immense value. Because if you know that, then you can get the pulse of the people you care about. Okay, you can take pulse of the people you care about. The fourth V is veracity, is the uncertainty of the data. Now, there's two parts to this uncertainty. One is this the kind of sarcasm or the intent that we don't really understand. We don't really capture fully from the data, from the unstructured data. The second uncertainty comes from the incompleteness of data. Now, when we talk about big data, we only talk about the size of the data sets. Oh, we have 60 million records. We have 100 million records. We have 1 billion records. We have terabytes of data. But is that terabyte of data, or how representative that terabyte of data is to the population is really unknown. Unless you're a company like Facebook, where you own or you have, as your users, the majority of the population. Unless you have that, then you don't have a representative sample. Okay? Now, I will go into some cases later on and talk about a major ride-hailing company in China called Didi, Chuxing.
Okay, let me stop a little bit. Okay, Professor Han เนี่ยก็วันนี้คือค่อนข้างที่จะไปทางคอมเมอร์เชียลมากนะครับเพราะฉะนั้นแกก็ยกตัวอย่างที่งานที่แกทำงานมานะครับก็คือว่าในเข้าเว็บไซต์เนี่ยนะครับใน e-commerce เนี่ยมันไม่เหมือนกับร้านฟิสิกอลทั่วไปที่เรามีผู้จัดการสามารถจะสังเกตสังกาอะไรได้งั้นลูกค้าที่มาเข้าเว็บไซต์เนี่ยถ้าจะสังเกตอะไรไม่ได้เลยอาจจะมีเขาเรียกว่าล็อกในเซิร์ฟเวอร์หรืออะไรต่างๆนะครับแต่ว่างานวิจัยของแกก็จะเป็นเรื่องพวกนี้แหละนะครับในการที่จะดูออกแบบโฆษณาบางอย่างที่ทำให้คนคลิกเข้าไปแล้วไปซื้อแยกลูกค้าอะไรไปได้ต่างๆเหล่านั้นนะครับอันนี้ก็กลับเข้ามาที่เรื่อง Big Data ที่แกนำเสนอเนี่ยนะครับก็เมื่อกี้แกบอกแล้วก็มีทั้งเยอะคือข้อมูลเยอะนะครับแล้วก็ข้อมูลยัง vary ก็คือมีความแตกต่างกันเยอะนะครับก็มาขยายตรงนี้นะครับก็โอเคตัวแรกเนี่ยเยอะทุกคนก็ชัดเจนนะครับตัวที่2เนี่ย velocity คือความเร็วนะครับเร็วหมายถึงว่าเป็นพวก data streaming อาจจะเป็นพวกหนึ่งที่มาวุบหนึ่งนะครับเหมือนเพลินคุณเสียพรอยู่แถวนี้ทีเดียวก็เหมือนกับ Google Map อ่ะใช่ไหมมันขึ้นมาสีแดงสีอะไรนะครับตอนนี้มันแดงแปลว่ารถติดเดี๋ยวสักพักมันก็หายไปนะครับคือเขาบอกว่าไอ้พวกนี้บางทีเราเก็บไม่ได้นะครับมาดูปุ๊บถ้าเก็บไม่มีที่จะเก็บข้อมูลแต่เราต้องดูแล้วรีบวิเคราะห์ทันทีอะไรประมาณนั้นนะครับและอย่างไอ้พวกนี้จริงๆแล้ววันหลังมีประโยชน์มากนะครับเนี่ยอย่างสมมุติว่าเนี่ยล่าสุดเมื่ออาทิตย์ที่แล้วใช่ไหมครับเราเพิ่งถวายอะไรนะถวายดอกไม้จันทร์ใช่ไหมครับถ้าคนรู้ข้อมูลพวกนี้นะครับก็จะรู้ว่าคนจะมาเยอะนี่หรอกใช่ไหมก็จะได้เตรียมตัวอีกแบบนึงดันเตรียมตัวอีกแบบนึงก็เลยไม่ทันผมเห็นแล้วไปตั้งแต่ตอนเช้าบอกโอ้มีคนมาคอยตั้งแต่เมื่อคืนโอ้โหแปลว่าอะไรแปลว่ากูมาสายไปแล้วคือถ้าน่าจะออกข่าวซะหน่อยนะว่าอะไรอย่างเงี้ยนี่หรอกใช่ไหมก็จะเลยมีปัญหากันยุ่งยากนะครับแต่ว่านี่คือ velocity เนี่ยนะ velocity เนี่ยก็คือความยากที่ต้องมีแต่จริงๆมีประโยชน์มากนะครับมีประโยชน์มากแต่ต้องวิเคราะห์ได้นะครับเพราะมันจะไปเร็วแล้วมันหลายอย่างตัวถัดไปตัวที่4ก็คือvariety นะครับ variety ก็คือแหล่งข้อมูลแหละนะครับเนื่องจากข้อมูลตัวนี้มันมาจากหลายแหล่งมาจาก Facebook มาจาก YouTube มาจากอะไรหลายอย่างนะครับซึ่งแต่ละแหล่งข้อมูลมันก็เป็นไงเก็บข้อมูลไม่เหมือนกันแล้วเขาอธิบายลึกไปกว่านั้นอีกก็คือว่าขนาดคำพูดเดียวยังไปแปลได้หลายแบบนะครับเพราะเราไม่รู้ว่ามันเป็นเซนหลายความ ที่ Big Data ก็จะต้องมาดูพวกนี้เหมือนกันนะครับเพื่อจะดึงข้อมูลออกมาแล้วตัวสุดท้ายก็คือเรื่องของข้อมูลมันไม่สมบูรณ์นะครับสมมติมันถูกแบ่งมาส่วนนึงจะเก็บไม่ครบหรือเรื่องต่างๆเหล่านั้นกรอกไม่ครบเป็นตัวที่ต้องเอามาประกบกันนะครับนั่นก็คือเราเป็นข้อมูลที่ fragment ไปหมดนะครับเหมือนอย่างบางทีอธิบายเดี๋ยวเรารู้เนี่ยภาครัฐจะเป็นแบบนี้เยอะแต่ละกระทรวงเก็บกันหมดอะแต่พอมาต่อกันแล้วเป็นไงมันยังขาดอยู่ว่ะ เรื่องคนส่งออกเนี่ยเก็บกันทุกคนแหละก็เอาไหมแต่ยังมี missing อยู่นะครับก็จะต้องพยายามที่จะแปลผลตรงนี้ให้ได้อันนี้ก็คือลักษณะของข้อมูลนะครับที่คือความจริงตรงนี้เป็นบอกว่าความท้าทายของอะไรครับ Big Data นะครับโอเค next
Thank you. So I'm going to bring up a case later on and explain a little more detail. There's a ride-hailing company like Grab, Uber, in China called Didi Chuxing. Okay, I'm not sure if you've heard of it. It's like Grab. So everybody uses Grab car. For ride-hailing, you don't have to get a taxi. You can book a car. Now they have, I think, about 96% of the market share of ride-hailing in China. That's tremendous, right? They have at their disposal, I don't know how many overall in China. I think 17 million drivers working for them. Okay. Now because of that, with all of the information that they have, all of the passengers that need rides from point A to point B, all of that data gives them tremendous insights about traffic flow in cities in China. That's true, right? Yes? Now, but that's still, even though they have 96% of the market share in China, that's still only a very small portion of actual traffic within the cities in China. It's only a small portion because there's a lot more private cars. There's a lot of other taxis. And there's a lot of actual private citizens driving their own cars within the cities. So if the city only had all of the cars in the city were Didi cars, then I would know the complete picture. But since, even though I'm extremely successful, I only know a very small, less than 10% proportion of the cars that are driving within the city, I cannot get a complete picture. That's where the uncertainty comes in. Okay? I want to do more. I want to understand traffic congestion within Chinese cities. I have the best data to be able to do that, but it's not enough. And that's the kind of challenges we have to tackle as a company or as an organization, as a government agency. Those are the kinds of challenges we want to tackle in order to get really high quality data. What are the different ways in which we can do that? So as a company, we want to create partnerships, and I'll talk about this later, partnerships with other companies, partnerships with the government to create more fuller data sets to better understand what's going on actually in order to create new services and new products that are of value. So we'll get into that. That will be kind of the main message of today's presentation. Okay, now I want to take some time to understand why we're talking about big data today. How did we get to this situation where big data has become important and ripe for discussion at this point in time? Now, so there's four main factors that are driving the phenomenon of big data. Okay, first is enterprise systems, second is social media, third is mobile, and fourth is Internet of Things. Okay, now so each of these factors, although unrelated, some are somewhat related, but mostly unrelated, provide different impetus for making big data ripe for today's taking. Okay, so first, enterprise systems. We've done since the early 90s. We've had 2 decades of investment in enterprise systems. Almost all companies nowadays, all large, even small, medium enterprises, are digital enabled, meaning they run enterprise resource planning systems. They have like HR systems. They have inventory systems. You cannot run a company without order management systems. Any e-commerce or online company would have a lot of their systems automated. A lot of their companies' operations run through with these systems. What this means is data is captured. Now we've already begun, and we've begun to capture data, at least internally. All of the operations data are being captured within the companies, within organizations. Okay? So we've created a context, an atmosphere, an environment where we have operations data, we have data on products, customers, sales, transactions, accounts, all of the things, and employees. All of these things are created into data sets and we manage them. And because we need to manage them, we've already developed the initial technical skills for the capture of the data, the transformation of the data, the analysis of the data, and the use of the data. Okay? So that's one factor. Okay? Because companies have already become digitized or digital enabled through enterprise systems, we've created a context where the next step is possible. We have the skills to be able to do it. And we have some of the data. Okay? Not all of the data. So at this point in time, I think it was in the early 2000s, and even my PhD research dissertation, we called this business intelligence. We didn't call it big data, we called it business intelligence. Okay, that was the term at the time. Now, business intelligence now became big data. Second factor is social media. Okay, now we have YouTube, Facebook, Vine, Twitter, Pinterest, Twitter, Snapchat, Instagram, all these things. What is that doing? What that's doing is that now we're able to capture people's behaviors. People keep doing what they love, but they leave digital traces of what they do. Okay? Now it's creating new data that's in digital form. Okay? People are continuing to do things. This is the kind of thing that we didn't capture before. Companies did not know that people liked that kind of dish. Now, because we have Instagram, and somehow people like taking photos of food. I don't know why, but people, if you go to a restaurant, people don't eat. People just take photos. It's so weird. I try not to take photos, but I have to wait till my daughter takes all the photos, and then I can start to eat. She won't let me start until she's taken all the photos. So people continue to do what they love. People live on with their lives, but they leave digital traces of it. People go to a restaurant, they check in on Foursquare or on Facebook. People, when they're traveling from one city to another, they check into the airport and then they say, I'm traveling to Bangkok. Okay? And then people comment on it and say, oh, have a good journey or whatnot. Okay? And people leave digital traces of everything that they do. It's the quantifying self movement. Okay? People go for a run. And then, they say, oh, I ran 5 kilometers in 30 minutes, right? People, how many of you do that? At least take photos of your food? Most of you? Okay. Now, how many people actually go back and look at those photos? Why do we take photos? I don't know. Okay, people continue to do this, but we leave digital traces. Okay? What social media is providing to us is a whole new realm of data about things we might be interested in. Companies might be interested in this thing. Okay? It's providing data that's more interesting than internal operational data. Now, if you think about enterprise systems previously, what did we capture? If you're the restaurant, you captured that customer, let's call her Jane. She bought, I don't know what that is. I have no idea what that is. She bought that dish. That's what we have captured. We know that on this day, November 2nd, 2017, Jane, a customer, bought, because we threw her credit card, we know that it's Jane. We know that she bought that dish. We know what she ordered as the drink. She ordered a Coke. Okay? We know how many people were at the same table. Okay? That part we know. That's all we know. Now, that's valuable, but we don't really know anything above and beyond that. Here, by knowing that she's taking a picture of it, we try to infer new information, new knowledge about it. Okay? Gives us more context into the transactions. Enterprise systems give us data, operations data, but it's not the data we really care about. It's reactive data. It's a historical record, but doesn't help us be imaginative, create new insights, create new strategies about what we want to do. It's this kind of real life understanding the customer data, understanding our stakeholders' needs, our stakeholders' aspirations, our stakeholders' desires. That's really important. So social media has started to give us that through, despite all of the difficulties of having unstructured data and things like that, it's given us a context where that's possible. That's social media. Okay, so enterprise systems have given us data and capabilities of analyzing data. Social media has given us contextualized data. Okay, the third factor is mobile. Now, everybody has a mobile phone. Some people have multiple. Okay, mobile has taken over PCs and laptops. So any kind of computer, like a desktop or a laptop, and that was in 2014-15. Okay, now we use mobile much more than we use laptops. Now, what is the difference between mobile use and a laptop or a PC use? What's the main difference? Size is a huge factor, but because of the size, what happens? It's the mobility. It's you go home and so I could take a picture with my digital camera, my Kodak digital camera. Kodak didn't go into digital cameras, but my Canon digital camera. Go home, take my SD card out, load it onto my PC, and then post it on Facebook. That's what people used to do. They were very dedicated. They had to actually plan out their whole day. Oh, I have to go home. I have to remember to transfer my photo into into my PC, and then I can upload to Facebook, right? Or Snapchat or Instagram, right? Now with mobile, now you're untethered. You don't have to do that. Okay, you can just take a picture with your phone, mobile phone, and upload it then and there. Okay, so what we have now is that we have data that's captured in the moment. It's much more contextualized. Okay, now if you had a PC, although laptops are mobile, it's still very cumbersome to do that. Now the distance between my urge to post, my urge to leave a digital trail, and my actual action of leaving a digital trail has become almost nothing because of mobile, because the phone is always there, the mobile phone, and it has these capabilities such as taking photos, the internet access to services like Instagram, and so you can do that instantly. So mobile or social media gives us contextualized data, and mobile gives us data in moment. Okay, real-time data in the moment. And so there's two aspects of this. One is there's a greater likelihood of capturing the data because people, if it's cumbersome to do it, I might not do it. And so it's capturing people's actual behaviors when it is actually happening. That's very important. It's providing a context where what we want to know is out there. Okay, the fourth factor. So most people, I don't know if you're like this, but 66% of smartphone users sleep with their phones next to them. How many of you sleep with your phones next to you? This is not 66%, so I think many of you have not raised your hands. But it goes everywhere. It goes to the toilets, it goes in your bed, it goes to the restaurant, it goes everywhere you go. Okay? And so you can capture what's happening in people's lives in the moment. Okay, the fourth factor is Internet of Things. Okay, now this is not, it's still a work in progress. There's a lot of work that needs to be done in this area because it's a tremendous concept. A lot has been done, but there's still a long ways to go. There's a lot of potential in Internet of Things. So what is Internet of Things doing? Internet of Things. So this is just one example. Okay. Now we are disentangling, we're detaching, okay, teasing out, decoupling the actual intent of sharing with the sharing. Now, even if I don't want to share, data is going to be captured through these sensors. Now, obviously, this is the Nike plus the running example. I clicked on share, that's why it's sharing. But when we have truly, come to the era of Internet of Things, all of the sensors, all of the CCTVs, all the sensors that are out there, whoever planted these wherever, are going to capture data in an unobtrusive way, without you knowing, without me knowing, and is going to capture the data for use in some context. Okay? So enterprise systems give us the capabilities, right? But there was limited momentum because it's not really exciting data. Okay, the data is there, but we analyze transactions, we analyze product sales. It's interesting, but it's not exciting. Okay, social media gives us meaningful data. Mobile gives us real-time data. Okay, Internet of Things gives us actual unobtrusive data on behaviors. Okay, what people did instead of what people thought. Okay, and so it's not me posting something about it. It's me. It gives us traces of things that it's about behaviors, not intentions. Okay, so these are the 4 factors that now lead us to say, well, here's really, really valuable data on what we can use for whatever purpose, but now we have the skills, and now we have really interesting and valuable data at our fingertips.
Okay, so จริงอันนี้ดีมากแต่ผมอยากจะแปลนิดนึงว่าจริงๆคือแหล่งข้อมูลของการทำ Big Data นะครับอันที่1ก็คือพวก EIP System ก็คือฐานข้อมูลที่เรามีอยู่แล้วนะครับจริงเขาก็พอยต์ไว้อยู่แล้วว่ามันคือข้อมูลในอดีตข้อมูลยอดขายในอดีตข้อมูลอะไรในอดีตของเรานะครับก็พอที่จะมาทำการพยากรณ์ทำอะไรได้นะครับแต่เขาบอกว่าด้วยโลกทุกวันนี้นะครับมันมีมากกว่านั้นนะครับอย่าลืมว่าอะไรนะสิ่งที่สำคัญที่สุดคือการอะไรเดาอนาคตเราอยากจะรู้ว่าผลิตภัณฑ์ใหม่ของเราคืออะไรใช่ไหม new product ผลิตภัณฑ์ใหม่ของเราคืออะไรความต้องการใหม่เป็นยังไงนะครับเราอยากจะไปเป็น market เป็นคนแรกใช่ไหมครับเพราะ product margin มันจะเยอะที่สุดตรงนั้นใช่ไหมครับเขาก็บอกว่าอย่างเงี้ยโซเชียลมีเดียนะครับไม่ว่าจะเป็นอะไรนะYouTube Facebook อะไรต่างๆเลยนะครับมันสามารถที่จะน่าจะเอาข้อมูลมาคาดการณ์ตรงนั้นได้เข้าใจบริบทอะไรมากขึ้นได้นะครับแล้วตัวที่3ก็จะเป็นข้อมูล Data โทษทีมาจากโมบายโฟนนี่แหละนะครับเพราะว่ามันสามารถจะล็อกเวลาไว้ที่ไปดั้งดูนะครับประกบกันนะครับถ้าเป็นสมัยก่อนที่เขาเล่าให้ฟังว่ากว่าจะกลับถึงบ้านไปลบอัปโหลดข้อมูลก็ผิดพลาดแล้วเราไม่รู้ว่าภาพนี้ไปถ่ายเมื่อไหร่ใช่ไหมแต่ว่าต่อไปนี้นี่ถ่ายภาพอาหารปุ๊บเราเริ่มรู้เทรนด์แล้วชอบกินอาหารมื้อนี้กลางวันโอเคเพราะถ่ายรูปมันถูกบันทึกเอาไว้ใช่ไหมครับนะแล้วก็เบอร์4ก็เป็นอนาคตนะครับอนาคตที่ว่าเริ่มอาจจะเข้าใจว่าเป็น behavior คือพูดง่ายคือเดินไปไหนแต่อะไรต่างๆแล้วเพราะทุกอย่างมันเป็นอินเทอร์เน็ตหมด connect นะครับเขาก็สามารถจะรู้จริงๆในภาพรวมในมุมมองของเขาซึ่งเป็นธุรกิจเนี่ยก็คือพูดง่ายคืออยากจะรู้อะไรพฤติกรรมของคนใช้เพื่อที่จะดีไซน์ตรงนั้นมากขึ้นก็มีความทั้งตอบง่ายๆก็คือ Big Data มีความสำคัญมากสำหรับธุรกิจสมัยใหม่นะครับในการที่จะ capture ในการที่จะแปลผลข้อมูลมาให้ได้โอเค thank you
all right so moving on so I'm going to cover so what is data analytics so how do we do it and things like that now from I presume this is fairly obvious and close to you and so from a organizational process point of view this is how analytics works, and it's the same as business intelligence. We have the real world. We have occurrences in the real world. This could be transactions. This could be sales. This could be accounts. This could be logistics. This could be products. Whatever it is, something happens in the real world, and we can collect the data. It could be social media. It could be Facebook posts, Twitter, anything. Anything happens in the world, somebody has to capture the data. So it's collected. That's raw data. Okay, that has to be imported. Okay, so there's this whole technological or technical process that happens. The IT departments are working towards creating the systems to capture the data, to collect the data, to store it. Okay, so the engineers and developers actually do this. Now, once all the data is imported into the company, some system, then it's going to be imported into a data warehouse where it's transformed, it's normalized, it's put in, it's structures are put onto it, it's going to be cleaned, and that data transformation happens, and that the database administrators will handle that. Okay? Now, next, the data is there, somebody's going to analyze it. This is the role of data analysts and data scientists. And that's the data analytics part. But the whole process is important to data analytics. Finally, we have reports. So we have reports, we have visualizations, we have dashboards, and we can all call them reports, and we use that to make decisions. Okay, decisions about what new products to launch, what kind of what business relationships to change, whatever it is. Some decision has to be made based on the analysis that was had in the analyzed stage. Now, the most important thing is this feedback loop. Okay, from the side back to the real world. You make some decision, it's going to change, and it's going to change something. You're going to change a product, you're going to change a marketing strategy, you're going to change something, And that's going to have an impact on the real world that's going to create new data, or we're going to see the impact of those changes in the real world from the data. And so you have to have this feedback loop where now we have an ability to test whether or not our decisions made in that last part. So we have decisions from these reports, we make a decision that's fed back, and now we have an opportunity to test whether or not our decisions were effective. That's very important. Otherwise, there's no point in doing this. Okay. Now, from a more data analytics process and tool point of view, these are the different kinds of technologies or tools that you've been hearing about. So this helps you to make sense of all of the different kinds of tools. So people do web crawling. We design. So if you have the data and you're capturing at your own server, you don't need to do this. But a lot of the data is available on other companies' websites or other companies' systems. And so you can use technologies, tools such as web crawling to go out to the world and grab people's Facebook posts. Or you can grab the Twitter posts. You can use APIs from Twitter to get the Twitter posts from the post on Twitter, posts on Facebook. All these different things you have to develop. You can develop systems for doing that. You can have your own server logs. You can have application logs. You have your mobile sensors. You have IoT devices that are all producing data, and that can be collected. Now, in the input part, it's not that interesting. We have server-side tools, the ETL kind of technologies, and then in the database side, we have the traditional relational databases. We have the more big data technologies such as Hadoop, cloud, things like that. Yes, please. Database administrator. Database administrator. Yes, database administrator. Okay, so technologies such as Hadoop, all these terminologies are related to how we capture, or we store and transform and we store the data, so that for future analysis. Now, in the analysis part, we have all these statistical technologies, tools, such as Stata, SPSS, R, Excel, and these are the tools that we use. Now, you probably heard Python a lot, right? Python, everybody, if you want to be a data scientist, you have to learn Python. Python fits into this part, this analysis part, as well as this collect part. Python is basically a programming language, but with very good libraries. So there's a good community of developers who develop very useful libraries. So Python is just like Java, but it has good libraries for web crawling. So things like Beautiful Soup is a library that's used with Python that you can use to scrape the web. And it also has a lot of numerical functions, network functions, and things like that in the analysis part. That's why Python has become one of the most useful tools for the analysis. R is less of a programming language, but more for a statistical package that allows you to make it programmatic, which is also very, very useful. Other packages such as Stata or SPSS kind of don't lack, but it's very difficult to get the actual analysis done in a programmatic way. That's why R has become much more useful today. In terms of the reports and the decision making, there's a lot of visualization tools. You've probably heard of companies and technologies such as Tableau, ClickSense. These are the different kinds of technologies that connect to your relational database or your Hadoop or your different kinds of formats of data analysis that's done through like R, data frames, to create the visualizations and dashboards that you can use, the managers can use to make decisions. Okay, so this is just an overview of the different technologies. So if you're not familiar with the different terminology, this gives you a kind of a map of where everything fits in. Okay, now, so what is data analytics? Essentially, it's the process of analyzing data sets to draw conclusions about the information contained in them, but it's essentially about recognizing patterns. Okay, it's pattern recognition. Okay, you're trying to recognize patterns. You have a lot of data, and you're trying to find a needle in the haystack. Okay, you're trying to identify patterns and say, what associates with something else? That's the goal of data analytics. What is the relationship between some factor, some variable, some data point, and some other factor, some other variable? That's essentially it. Okay? Once we know that, then it enables, once we know the relationships, and we know that these relationships are robust and stable, if we know that if we increase something, if we increase, let's, crudely, if we increase marketing budget, advertising budget, our sales are going to go up by how much? If we know that relationship, if you have knowledge about that relationship, then obviously if you want sales to go up, you increase the marketing budget. Okay? So it's that kind of knowledge, those kinds of association rules that we want to extract from the data. But it's much more complex than that. Okay? There's a lot of complexity here. So the patterns enables decision making. Okay? It gives you, so you want to understand or recognize patterns that relate to important decision related phenomena. Okay? Now once you've done that, it helps to optimize operations. Okay? And so one, the human injected decision cycle would be I do the analysis, I find the results, and I make decisions to change. Now with the cognification technologies that Bert talked about earlier, we can automate that process. We don't need the manager anymore because we know what we want to do, and we can take the manager out and optimize the decisions such that if we find this kind of relationship, then we know what the next step will be. We know what the next decision will be. Okay? All right. So now, so essentially this is data analytics. Hopefully we want to get to this optimization stage. We're not quite there yet, but with artificial intelligence and cognification technologies, that's coming very quickly. So if you're a manager making decisions, you have to be scared that your job might be at stake. You might lose your job very soon. But that's coming. Okay? Now this is becoming, again, because of the 4 factors, it's becoming more and more ubiquitous because of rapid progresses in IT, the ERP, social media, mobile, IoT. If you get a grasp of how much data, this is 4 years old, but still, this is the sheer volume of data that's generated every minute in 60 seconds of every day. We have 4.16 million Facebook-like clicks in 1 minute. Okay? You have 300 hours of YouTube videos watched. You have 1.7 Instagram photos liked. Okay, you have, I don't know if people use Tinder here in Thailand, but over 500,000 people swipe left or right on Tinder. This is an online dating application. Okay, all of this data is happening every minute of the day. Okay, every minute. This is the sheer scope and scale of data we're talking about, and that's all accessible to everybody. All of this data is accessible to everybody. Okay, through APIs and whatnot. But if you're this company, this is the kind of data you have to deal with. Your own internal data. Okay, that's becoming more and more important to do data analytics. Okay, so we need to talk about the different kinds of, different types of analytics kind of objectives. And so we typically in academia, we classify analytics into 4 different types, okay, depending on the objective. So we have descriptive analytics, where the main purpose of descriptive analytics is to answer the question, what happened? Okay, is there something interesting that happened in my data? So this is identifying the pattern, recognizing a relationship between variable A and variable B. That's descriptive analytics. Did something actually happen? Next is diagnostic analytics. We are answering the question, why did it happen? Okay, so instead of just knowing A leads to B or A is associated with B, in diagnostic analytics we're saying, why did A lead to B? So we're trying to provide this causal relationship. Okay, it's not just A is associated with B. And so a classical example in data mining is that somehow a grocery chain in the US was doing this data mining, like analyzing data, we used to call data mining, on their transaction data. And they found that people who bought diapers for babies also bought beer a lot. Okay, so in the shopping carts, you have a lot of baskets with diapers and beer at the same time. So what is this telling us? A lot of drunken mothers, or
Father shopping
What?
Father shopping
Father is shopping? It could be. No, but the descriptive analytics is beer and diapers are bought together very frequently. As if you're the manager, what do? You put beer and diapers next to each other. That's the obvious decision, right? No, but when you get into diagnostic analytics, you have to understand why did this happen? Okay? And so you have to really understand, look into the data, and they did further analysis, and figure that that relationship, diapers and beer, usually happen on Saturdays. Okay? And so the father goes shopping, and the father wants to buy beer for the big football game on Sunday. Okay? So we need further insights, context about how to interpret the data so that we know how to make better decisions about it. Just putting diapers and beer next to each other is not going to help, right? And we're not catering to drunken mothers here. We're trying to cater to the fathers, okay? Making better signs for the fathers to know where the diapers are. That could be an interesting intervention that could have been done if we know that thing, okay? Now, the next step, so once we know why did it happen, then we understand kind of the causal relationship. Okay, we know the reason for that observation, actually, or the pattern being recognized. A lot of times we group descriptive and diagnostic analytics together because it's not just about identifying, but we always have some hypothesis in mind. Okay, when we do the analysis, so we want to test whether or not A is actually related to B. Okay, so usually those two go together. The next step is predictive analytics. This is what will happen. Okay, this is about forecasting. This is about knowing whether or not, or having confidence in whether or not, if we do something, will we see in the future. We haven't. It's not about analyzing past data, but it's having more confidence about if we engage in some intervention, will what we expect happen? Okay, so this is forecasting. Okay, here, in the main difference between descriptive and diagnostic analytics with predictive analytics is the focus. The focus is on reliability of the findings, robustness of the findings for descriptive and diagnostic analytics. Okay, we want to make sure that the knowledge that we gained from the analysis is valid. Okay? And so if the concern would be on things like the statistical significance of a relationship, right? So if we have highly statistically significant relationships, then we have more confidence that this construct or this factor, this variable actually is associated with that variable, right? Now, with predictive analytics, it's not really about the robustness of that relationship. It's more about the accuracy of the prediction. Okay? Now, think of it this way. If you had a model or a algorithm that could predict the stock price of companies in the future, would you care more that you understand why it's happening, or only care about that it's going to be accurate? Okay, here you're only concerned about or interested in the accuracy of the prediction. The model itself can be completely a black box, but it's fine. Okay, so this is where there's a big divide between the different kinds of analytics. If you think about, you've heard of things like deep learning. Everybody heard of deep learning? Neural networks, convoluted neural networks, all these things. You've heard about these things. Deep learning is a fabulous, wonderful technology for predictive analytics, for classification. So we know, we train the data with with historical data. What we really want to know is, given an unknown new data, what will happen in the future? If that accuracy is high, then we have good predictive analytics. Deep learning does not give us any understanding about why that's happening. It's a black box technology. Okay? You train it, it will give you the right results, but it doesn't give you any kind of understanding. Okay? Now, some might not care. If you're a investor and you want to know the stock price of tomorrow's the company in tomorrow's market. It doesn't matter. But in order to truly become, have insight about what's happening, you also want to know. You should care about the robustness of the relationship, in addition to the predictive accuracy. Okay. Now the holy grail of data analytics is prescriptive analytics. This part, it's still a work in progress for most organizations, most analysts, because this is where we really know where we can really achieve optimization in this whole data analytics process. This is answering the question of how can we make it happen, make something happen. Okay, here we really need to have predictive accuracy, but we also need to know the causal relationship. It's not just associational, it's not just correlation, but we need to know the causal relationship such that if we manipulate variable X, then we know what's going to happen in variable Y, such that we have the complete feedback loop. This is when cognification and the optimized, automated decision processes, automated kind of adaptive learning could actually happen. Okay, this is still in the future. We haven't achieved this part yet, but this is the holy grail of analytics, where we really want to understand the causal relationship between phenomena in the world, such that if we change something, if we give an intervention, we know what the next T+1 world will look like. Okay?
โอเคก็นี่เขาก็ชี้แจงนะครับอันนี้ก็เป็นวิชาการก็เป็นว่าชนิดของ Data Analytics มีอะไรบ้างนะครับอันดับแรกก็จะเป็นเรื่องก็คือเรียก Descriptive Analytics ก็คือการเอาข้อมูลสถิติมาวิเคราะห์นะครับว่าเกิดอะไรขึ้นนะครับอาจจะโชว์ขึ้นมา High Low ด้านสถิตินะครับแล้วเสร็จแล้วก็จะหาความสัมพันธ์ก็อาจจะหาที่ได้ว่ามันเกิดจากอะไรนะครับทำไมอุณหภูมิสูงของเสียเยอะอุณหภูมิสูงคนไปห้างเยอะอะไรต่างๆเหล่านั้นนั่นคือความสัมพันธ์นะครับที่ว่าทำไมมันเกิดขึ้นได้นะครับแล้วก็ถ้าเป็นไปได้ปุ๊บเนี่ยก็สามารถจะพอมีข้อมูลเยอะเข้านะครับก็จะมีการ learning พวก AI อะไรพวกนี้นะครับที่เขาบอก deep learning ก็จะเป็นการพยากรณ์ไปข้างหน้านะครับการพยากรณ์ไปข้างหน้าคือว่าคาดเดาว่าหลังจากเหตุการณ์อย่างนี้นะครับมันก็จะนำไปสู่ว่าอนาคตจะเกิดยังไงนะครับเพราะคำว่าพยากรณ์เนี่ยต้องบอกงี้ว่ามันก็มีตั้งแต่ระยะสั้นเช่นพรุ่งนี้จะเกิดอะไรขึ้นเดือนหน้าจะเกิดอะไรขึ้นปีข้างหน้าจะเกิดอะไรขึ้นนะครับเสร็จแล้วเขาก็จบตรงที่ว่ามันมีอีกแบบหนึ่งก็คือ prescriptive analytics นะครับคือว่าไอ้อย่างที่3เนี่ยเราคุยกันเป็น AI หรือพวกนี้มันเป็นกล่องดำมันไม่รู้มันแค่บอกว่ามันจะเกิดอะไรขึ้นนะครับแต่ว่าถ้าเป็นอย่างสุดท้ายที่เขาบอกว่าทุกวันนี้ยังพยายามจะหาวิธีนี้อยู่นะครับพยายามหาวิธีนี้อยู่ก็คือว่าพยายามจะบอกให้ได้ว่าทำอะไรถึงจะเกิดอย่างนั้นนี่ว่าต้องทำอะไรถึงจะได้เป้าหมายอย่างนี้คือได้ความสัมพันธ์แบบนั้นเลยนะครับควรจะปรับราคาแบบนี้แล้วเดี๋ยวเป้าหมายจะได้อะไรผมยกตัวอย่างให้ฟังกันที่พูดเกินเขานะครับเพราะว่าอันนี้ก็จะเป็น research ของนักวิจัยที่เขาจะต้องพยายามตอบโจทย์ตรงนี้อยู่นะครับแต่ว่าทุกวันนี้เนี่ยเครื่องมือที่มีอยู่เนี่ยก็จะตอบไอ้3อย่างข้างหลังได้นะครับงานอย่างที่4ก็จะเป็นงานวิจัยอยู่นะครับโอเค
Okay, so getting back to some details here. Descriptive diagnostic analytics. There's different kinds of techniques. You use summarization techniques such as averages, median, min, max. Looking at the data distribution. Is it normal? Is it skewed? Through this kind of descriptive statistics, we can infer a lot about the data. Okay, we're looking at relationships between two variables. Okay, so multivariate analysis with correlations. That's the main, or with regressions. Okay, so regression analysis, correlational regression. We can do, slicing and dicing, grouping the data, looking at female customers versus male customers, looking at different partitions, old versus young, all these to create further insights and checking whether or not the data for one group is different from the data from another group, right? So if you have the purchase dollar amounts for female, and you have the purchase dollar amounts within a store for males, and you calculate the difference between the two, and checking whether or not the difference is positive or negative, gives you some insights or statistical insights about whether or not the purchasing behavior for males versus females is different, right? Who buys more, who buys less? Okay, so this is basically the kinds of analysis that you do. Usually, the analyst has some hypothesis in mind, so that it guides the decision process. So if I'm an analyst and I think, oh, does gender have an effect? This is the kind of analysis that I would do. The main thing here is to explore the data to tell a story. Okay, understanding the story. It's the beer and the diaper example. We want to understand, make sense of it, to really understand what's happening here. Okay, so these are the different techniques that's used. Okay, now if we get into predictive analytics, here we need to identify the cause-effect relationships. Okay, this here. The cause-effect is in the next slide. I'm sorry, it shouldn't be here. So it's not the cause-effect relationships. Here we want to basically understand the patterns, just the patterns, and we care about the predictive accuracy. Okay, so we have techniques, statistical techniques such as classification. So if we go into technologies or algorithms such as support vector machines. We have naive Bayes, we have decision trees, we have random forests. These you might hear these terminologies. These are all classification technologies. Forecasting is also like regression can be used as a forecasting technology. Clustering is basically grouping the data without really knowing what values the dependent variable is. Things like text mining would be used for understanding the sentiment of or extracting information about unstructured data, and this would be used in the predictive analytics. We don't really understand why something's happening, but we all want to have good associations, classifications. We want to have robust predictions about whether or not, if we see this, that's going to happen. That's all. Okay. Now when we get into prescriptive analytics, this gets much more complicated. Here we need models. Okay. And we know the world is nonlinear, and it's not a linear model. It's a nonlinear, complex, dynamical system. So we need things like structural models. We need things like computational models to understand that if we change one variable, it's going to impact another variable, but through a feedback loop, it might impact another variable. So we have to understand the whole network of relationships. Okay. Now, so here. It's still a very complex area of study, and a lot of academics are working on this in understanding how to derive these models such that we understand it's not these simple linear models that we have, the regression models, but we have a better understanding of how the world actually works. So this is the holy grail with nowhere near reaching that stage yet. Okay, so these are the different techniques used. I'm not going to cover these in detail. Okay, but just giving you a landscape of the different techniques, statistical techniques that are used. So if you hear about, let's say somebody's working on classification, then you know it's about predictive analytics. It's about accuracy. Accuracy is most important. So if somebody proposes a predictive analytics or classification algorithm, the main question you should be asking is the accuracy or the recall, greater than what we already have? Okay, what we have in the state of the art. Okay.
A little bit because okay. Can you go back one slide, 2 slide please? Okay. อย่าง descriptive เนี่ยจริงๆนะผมบอกเลยว่าพวกคุณเนี่ยทำกันประจำแล้วนะครับคือ Max Min ทำบน data ใน Excel เนี่ยทำอยู่เป็นประจำนั่นเองฉะนั้นผมเคยเล่าให้ฟังตั้งแต่ตอนต้นว่าเด็ก MBA ก็จะประมาณนี้แหละนะครับคือจริงทำอยู่แล้วนะครับ Can you move next slide please? นะครับคราวนี้ถ้าเกิดลึกมากขึ้นก็ทำสมการสมานถดถอยให้ใครจำได้ถ้าตกสแตทก็ช่วยไม่ได้มันคือสแควร์แถวนี้ก็จะเริ่มยุ่งตรงนี้นิดนึงนะครับทำ forecasting model ทำพวกเรียก classification การแบ่งกลุ่มการจัดกลุ่มนะครับซึ่งจริงๆ MBA พวกนี้เรียนหมดนะครับแต่เด็กส่วนใหญ่ลืมนะครับแต่ว่ายังไม่ยากพอไป Can you move next นะครับที่เหลือก็คือจะเป็นเรื่องของการสร้างสมการละนะครับเรียกว่าโมเดลนะครับนี่จะยุ่งหน่อยนะครับแต่ว่าจริงๆแล้วก็บอกว่าจริงๆผมคิดว่าโดยหลักการเนี่ยวิธีแรกเนี่ยคุณจะทำอยู่เป็นประจำอยู่แล้วล่ะนะครับเพียงแต่ว่าเราไม่เรียกว่า Big Data อะไรเท่านั้นเองนะครับอย่างที่2ก็จะเป็นเทคนิคขึ้นมาหน่อยพวกนักสแตทนะครับพวกถ้าเป็นเอนจิเนียร์หรือว่าถ้าเป็นนักวิทยาศาสตร์แล้วก็เป็นนักสถิติเนี่ยจะใช้ประจำนะครับแค่เข้ามาไอ้ตัวสุดท้ายเนี่ยก็จะยุ่งหน่อยนั่นเองนะครับแต่ว่าก็มีคนทำอยู่เยอะพวกยกตัวอย่างเช่นพยากรณ์อากาศเนี่ยเขาใช้อยู่เลยนะครับI say forecasting the weather they usually develop this kind of thing they put some variable ที่เขารู้อยู่แล้วว่ามีความกดดันอากาศเท่าไหร่มีน้ำฝนเท่าไหร่มีอะไรเข้าหลายแฟกเตอร์มารวมกันเป็นโมเดลแล้วก็พยายามที่จะ forecast อนาคตประมาณนั้นโอเคครับ
Okay, so back to that. So far, from what I've said, you might be thinking, is data analytics the same thing as statistics? You might be thinking this, yes? A lot of you might be thinking, oh, it's basically statistics.
just translate like that okay
Yeah. So far, people might be thinking, data analytics, it's basically statistics. But it's slightly different from statistics. Well, big data analytics is different from statistics because of a number of kind of features. There's a lot of analysis pitfalls. It becomes much more difficult to analyze big data or large-scale data. So you all understand the concept of type 1 and type 2 errors.
I don't think so
No, okay. There's two. In statistics, we have two kinds of errors. We can say a statement when the statement is wrong. That's called a false positive. And so if you have a man and the doctor says, oh, you're pregnant, that can't be true, possibly true, right? Maybe the man is really fat or something, but the diagnosis, the conclusion, you're pregnant, is a signal. The signal shouldn't exist, but you're detecting a signal that doesn't exist. That's type 1 error. Type 2 error is saying that something doesn't exist when it exists. Okay? So, the woman is pregnant, but the doctor's saying, no, you're not pregnant. Okay? So that's type 2 error. When we have large-scale data, okay, the rate of type 2 errors goes down dramatically. Because we have a lot of data, the type 2 error, with a greater sample size, type 2 error just diminishes. It's almost zero now. Okay? We'll never be able to say with a big data that you're not pregnant when somebody's pregnant. Okay? If the signal is there, we'll identify it. The problem with big data is that we have increased tremendously the rate of type 1 errors. We're going to identify patterns of data, the patterns in data where a relationship doesn't exist. Okay? There's no relationship between A and B, but because we have so much data, anything will be statistically significant. The statistical tools will extract patterns that don't really exist. So discerning between real patterns and unreal patterns, or non-existing patterns becomes tremendously important. Okay? Now, this is critical, especially when we consider the human aspect of the data analytics process. Okay? When you have a company, many of you within your organizations might have a data analytics unit with data scientists. You've gone out and you hired data scientists. You have people, some IT people working on cleaning the data, transforming the data, and you have these data scientists working, tirelessly on analyzing the data. They come to you with these new insights that they generated from the data. And you're thinking, well, that's not possible, right? But the data analyst is telling you, yes, it is possible, and it is so robust that it cannot not be possible. Okay? There comes the tension. The managers don't believe you, but the data tells you something. Okay? So creating an organization where the managers are receptive to and open-minded to this kind of new insights that's generated. Because if data analytics is only giving you confidence about the knowledge you already know, right? If it's only confirming what you already know, then it's already failing. But we really don't know whether the analysis or the patterns that you've recognized when you do data analytics is actually a type 1 error. We don't know. And it's impossible to know. And that's the challenge. Okay? So type 1 error rate goes up tremendously and type 2 error rates go down tremendously. Now what's worse? Type 1 errors could be quite challenging, quite bad. Okay? Now consider these couple of examples. Okay, when we only look at correlations, there must be a relationship. Because when you have a lot of data, you're going to run into these kinds of situations. You're going to see correlations in two variables that cannot possibly be there. So for example, here, when you correlate the total revenue generated by arcades are these shops that have video games, okay, and you go in, you put your coin, and then you play video games. Okay, and so the revenue generated by arcades correlate that with the computer science doctorates awarded in the U.S. You have a 98.5% correlation. Maybe a lot of the computer science graduates, only computer science doctorates are playing in arcades. Maybe that's true, but unlikely, right? But it has a 98.5% correlation. This is really, really high. Okay? Now, is this a type 1 error? Most likely. But you're going to get this kind of situation. I have a few more funny ones. Divorce rate in the state of Maine. It's a small state in the northeastern part of the United States. If you correlate the divorce rate in Maine with per capita consumption of margarine, the fake butter that you put on your bread, margarine. So per capita consumption of margarine and the divorce rate in Maine are correlated at 99.26%. What this means is, if you want to reduce divorce rates in Maine, you should not sell margarine at all, or sell less of it. Okay, then you'll reduce divorce rates in Maine. Just another one for kicks. U.S. spending on science, space, and technology has a 99.79, this is 99.8% correlation with suicides by hanging, strangulation, and suffocation. So if you want the suicide rate to go down, you should not invest in NASA. Okay? You're going to, if you have a lot, this is real data. This is real data. This is real analysis. Somebody actually does this analysis to find weird, spurious correlations from data.
I think it's the scientists when they realize what their budget was going to be for the year.
they hang themselves. Okay. So now, that context tells the story of why this correlation happens. But we have suicides in the thousands, right? These can't all be the scientists. Okay, so this is the kind of type 1 error that you observe. Now these are obvious. Obviously, even very open-minded managers would see this and just discredit this kind of analysis. Okay, but these are clear-cut, obvious cases. Most of the cases brought to you as a manager will not be as clear-cut. Will be slightly kind of weird, but you might be thinking, well, that could happen, right? That could happen. And so you need to be very cautious about type 1 errors. So data analytics is not the same as statistics. Well, it uses very similar techniques, but the challenges are slightly quite different. Okay? We will have a lot more patterns detected, and it's really sifting through those to really identify which are the valid patterns and which are the invalid patterns that become really interesting. Right now, statistics doesn't give us that technique. Okay, it's human intuition. It's the analyst's intuition, and it's the discussion, the collaboration, the communication that happens between the analysts and the managers that resolves these issues. There's no technical, algorithmic solution to be able to do that. Okay, so it's only through this kind of questioning of the data, doing further analysis to make sure that this is, something else is related to this or something else is driving this that allows us to make that conclusion. Okay?
โอเค so เมื่อกี้เขาก็ชี้ให้ดูนะครับว่าไอ้ data เนี่ยมันเหมือนกับผมบอกแล้วว่าพื้นฐานสถิติแต่เขาบอกจริงเวลาใช้เนี่ยสถิติเนี่ยบางทีมันก็ผิดพลาดคือมันไปโชว์ว่ามีความสัมพันธ์อย่างแรงเลยแต่ความจริงมันไม่มีความสัมพันธ์นะครับแต่ว่าอันนี้มันเป็น type 1 error ก็คือว่าเขาบอกว่าถ้าใช้ big data มีโอกาสจะเจอเยอะคือเจอแบบนี้พี่แต่เราก็ต้องมาวิเคราะห์ข้อมูลแล้วดูซิว่าเป็นไปได้หรือเปล่าพี่แต่เขาบอกว่าในชีวิตจริงอ่ะมันจะยากกว่านี้เพราะว่ามันอาจจะเป็นไปได้หมายถึงว่าเราดูข้อมูลแล้วมันอาจจะเป็นไปได้นึกออกใช่ไหมอาจจะเป็นไปได้มันก็ต้องมานั่งวิเคราะห์หาสาเหตุอะไรมากขึ้นนะครับส่วน type 2 error ที่เขาบอกก็ถ้าใช้ big data บอกว่าโอกาสเกิดขึ้นน้อยเพราะ data เขาเยอะนะพูดถึงเป็นล้านเรคคอร์ดเพราะฉะนั้นโอกาสที่จะพลาดตรงนั้นจะไม่มีส่วนใหญ่จะมีแบบนี้มากกว่าก็คือว่าเจอความสัมพันธ์แต่อธิบายไม่ได้นะครับก็จะเป็นแบบนี้โอเค
Next, I want to discuss, because there's a lot of confusion about artificial intelligence and data analytics, just try to set the landscape of what AI and data analytics is about. After that, we'll take a break, and then I'll get into some case examples. So this is the last of the boring parts. Just bear with me for five more minutes. Okay. So data analytics and artificial intelligence, they are often talked about together, but they do similar things. It's about identifying patterns. But they come from different traditions. So data analytics comes from more of a statistical tradition, and artificial intelligence comes more from a computer science, machine learning, and algorithm tradition. Okay, so some of artificial intelligence is statistics based, but most of it is mostly algorithms. Okay, it's really about understanding the different ways of slicing and dicing, but not really related to like statistical distributions and whatnot. Okay, they do similar things, but have a very different objective. Okay, artificial intelligence wants to be accurate. It's about prediction. It's about accuracy. We don't want an AI-enabled car, self-driving car, to be, to have doubts about its driving trajectory, right? You don't want it to say, well, I think what's in front of me is a person, but I only have 99.2% accuracy, so it's not high enough. I'll just run through and hope for the best. That cannot happen. We need almost absolute certainty about the analysis or the predictions, or about the conclusions that we draw. Otherwise, you can make mistakes. Okay, so we want to get extremely high accuracy. Okay, whereas with analytics, we have a bit more leeway in terms of the accuracy, but it's really about understanding, because we want to change the world. Okay, it's not. We want to change the world in the way that we want to intervene. Okay. Now there's an intricate relationship, because AI has become more useful because of the variety and veracity of big data, of the unstructured data. Okay. And of the uncertainty of the data. Okay, we have a lot of unstructured, like text data, and so machine learning or AI techniques such as text mining or topic modeling, these kinds of techniques, traditionally from artificial intelligence, have become much more useful. And so we use AI techniques very commonly with data analytics. If you see the kinds of research people are doing nowadays, or some of the things companies are doing with data analytics, is actually a lot of it is based on AI. I'll talk about some examples later on. I mentioned Didi Chuxing, the ride-hailing car company before. They are now thinking of incorporating cameras in each of their cars. Okay, what they want to do with the cameras is not like shoot videos of inside the car, but shoot videos just of the lanes. Okay, now when you have a view of the lanes, okay, it's recording the lanes. What it's looking at is whether or not you're changing lanes a lot. Okay, they want to promote driver safety, safe driving. Okay, because that's of value to users of Didi. Okay, now in order to do that, their kind of intuition is that we want to understand driving behaviors, drivers' driving behaviors. The best way to do that is to actually look at how they're driving, and the way to do that is to capture in video the images of the car actually moving. Okay? Now, that's a great idea. But how does video of the car moving enable you to infer anything about drivers' reckless driving behaviors?
Again, please. Again.
So how does having video or images, like snapshots of images of the road in front of the car, give you any knowledge about the reckless driving behaviors or the safe driving behaviors of the drivers?
เขาถามว่าทำไมการเห็นภาพถนนเนี่ยถึงสามารถจะคาดการณ์พฤติกรรมคนขับได้เห็นแล้วมีประโยชน์ไงครับ
Okay, so if you know lane changing behaviors, right? So if you're a camera, what do you see? You see asphalt, and you see occasionally white or yellow lines, and you see you're a camera and you see a white line go by, or a white line go by. And you can detect, or if you can detect that, if you can have an algorithm that detects, that captures, in a still image, a white or yellow line in parallel, slightly slanted or something, and based on how slanted it is, the speed of the changing lanes. You can reverse engineer to calculate that, right? And you can, if you can detect the changing lanes behaviors and the speed at which you're changing lanes, then you can create a model that says, well, the frequency of lane changes and the speed and all this put together can classify the behavior of drivers into reckless versus safe, right? So you can think about it, you can imagine those kinds of possibilities, right? But if we don't have the algorithms to detect the lane in the image, if we don't have image processing algorithms, it's the same as facial recognition algorithms, right? So if you see like a circular thing with a dark something with, with some shapes in the circle, how does a computer know that it's a face and not something else, right? And so it's basically artificial intelligence techniques such as facial recognition or image processing that helps us create data or create knowledge about or capture data about the behaviors that we're interested in. This is where AI is becoming more and more useful. When we have sensors, data from sensors, from IoT devices, from people, the wearable computing devices, all of that's coming in, but we want to interpret them. We want to contextualize them. We want to understand what that means. Then, the AI technologies are helping us with the classification, okay? Telling us this is reckless, not reckless. It's the combination of these technologies help us in structuring the data so that we can use it for analysis and conclusion and decision making. Okay, so that's the relationship between analytics and AI. Now, if you think of you'll hear a lot about AI in now and in the future. Basically, AI, the whole field of AI related to analytics, can be classified into these four techniques. So there are things called supervised learning. There are things called unsupervised learning. It's a glorious way of distinguishing between. So supervised learning is when we know the answer. Okay, we want to build models that help us do classification when we know the answer. Okay, so in supervised learning, basically it's about classification. It's about training a data set, training a model with a data set, and making sure that if we have a test data set, we can get accuracy. But we need to know the ground truth. We need to know what happened so that we can train it. Okay? So a lot of the deep learning technologies or the applications would be like this. Okay? Now with deep learning, we can do great facial recognition, image recognition. Okay, that's been done. That's one of the great implementations of deep learning. Now, apparently, there was a computer scientist at was it at Facebook or Stanford? He developed a deep learning model. So, at Stanford, he developed a deep learning model to be able to distinguish between gays and not gays. So, homosexuals and straight people. There was a recent research paper about that. So he's getting a lot of negative kind of attacks from a lot of sides from that. But it's really, really accurate. So he goes through Facebook, gets all the profile pictures, and he can classify with extremely high accuracy whether or not you're gay or not gay. Politically very controversial. But AI technology is that good. Deep learning is that good. Right? So if we have enough, so Facebook has enough data where people have disclosed their sexual orientation. So you train the model with that data. Now you have new data where the people haven't disclosed their sexual orientation. And so we can use the trained model on the new data to create classifications. This is based on the past data. This is likely to be class A. This is likely to be class B. So that's supervised learning when we already have some knowledge about the right ground truth classifications. Okay, so we can, with future data, we can classify correctly. With new input, we can know how it relates to past input. Unsupervised learning is when we have data, when we want to classify data, but we don't know how to classify. We don't know the dependent variable. We don't know the classes that we're classifying. So this is basically about slicing and dicing. Okay? So we want to find, we have a whole data set. Basically, we want to find groups of data. We don't even know how many groups within the data we have, but we want to find different clusters or groups of data that are similar to each other, but different from other groups. Okay? So maximally similar to one another, but minimally or maximally different from other groups. Maximally similar and maximally different from other groups. Okay, so things like k-means clustering, hierarchical clustering, or detecting outliers, these kinds of techniques would be considered unsupervised learning. We don't know, what the groups are, how many groups there are, but we want to find different groups so that we can make inferences about them. Once we have classified the groups, then we can say, well, what are different between these groups? But otherwise, we just basically have a lot of data. Okay, that's unclassified. Okay. Third is reinforcement learning. This is for real-time adaptation. Okay, so things like genetic algorithms, Markov decision problems. These are some of the technologies used. Basically, what we're doing here is we want to develop models that learn over time. Okay, it's not about here's a model and we do it offline, where we have a model, we train the model, and then given this new picture, is this person likely to be gay or not gay? That's not the intent. It's more, if you have real-time data, what decision do we have to make at this time? So self-driving cars, reinforcement learning becomes really, really important. Okay, so we want to make decisions, and it has to learn over time, such that if I observe a new image, okay, so it's the first time I observe this kind of thing in front of me as a car, I don't know what it is, but if I have to make a decision about it, which is avoid or just go through, because it could just be a patch of oil on the asphalt, right, or a patch of water. But if I make the decision, I need to understand the consequence of that decision. Was it a good decision, a bad decision? And then reward if it's a good decision, or penalize if it's a bad decision, such that next time I encounter a similar situation, I either reduce my likelihood of making the same decision or increase my likelihood of making the same decision. So the machines have to learn over time to become more and more accurate over time. So that's an area called reinforcement learning, which is used for real-time adaptation behaviors. Now, a big area is making sense of unstructured data. As I mentioned, the social media, IoT sensors are creating a huge amount of unstructured data. So things like text mining, sentiment analysis, topic modeling, or LDA is a very common topic modeling approach, or natural language processing will be in this area of artificial intelligence. Basically, we have so much text, and it's unstructured, we can't use it. We need to summarize it. And so we have a large when we have a large corpus of text, we have 10 million tweets, just in a week. And how do we classify them? What are the tweets saying about President Donald Trump? Is it negative sentiment? Is it positive sentiment? When a new initiative gets passed or announced at the White House, and then you get all the Twitter input from all the Twitter tweets, then you analyze it. You can't read through all the several millions of tweets that are going through, that are coming out. And so we need these kinds of algorithms to be able to summarize and understand what's happening in the real world. But it's very difficult. Unstructured data is very difficult. Extracting, what are the topics of this, discussion, that would be more like understanding what the content of the message is. When you have more specific objectives about things like sentiment analysis, when we want to know is it positive or negative, it's much more focused. But even that's still very difficult because of things like sarcasm and whatnot that I've discussed earlier. Okay, so these are the commonly discussed or talked about techniques in artificial intelligence. So having knowledge of this will help you to understand. If somebody proposes, we need to do a k-means clustering on this kind of data, you know that it's about it's unsupervised learning. It's about clustering or creating groups of data sets, subgroups of data sets that are different from other groups but similar within groups. So things like that. So having a knowledge of this landscape, I think, is very useful. Okay, so I think it's time for a quick break.
Yeah, summarize just quick here. จริงๆ professor ให้ดีเทลเยอะเลยนะฮะถ้าใครอยากจะรู้เรื่องเนี่ยก็ไป search I say you give a lot of keywords techniques yes to go about but จะ conclusion ก็คือง่ายๆก็คือว่า data analytics เนี่ยก็คือเราต้องตั้งข้อมูลเองวิเคราะห์เองทำอะไรเองนะครับอาจจะมีเครื่องไม้เครื่องมือช่วยแต่ AI เนี่ยมันจะวิเคราะห์มาแล้วเพราะฉะนั้นเวลามันตัดสินใจเนี่ยเราพูดถึงแบบว่าตัดสินใจได้ภายใน1 วินาทีหรือเร็วกว่าวินาทีแต่ถ้าใช้ Analytics อาจจะใช้เวลาสัก 2-3 ชั่วโมงในการวิเคราะห์ข้อมูลต่างๆนะครับ AI มันถูกทำมาเพื่อตัดสินใจได้เร็วเอาไว้ในการ control อะไรต่างๆเหล่านั้นนะครับก็เป็นที่มาของการใช้ที่แตกต่างกันโอเค
Okay, so now we get to more interesting case studies. I wanted to show you some cases of how various organizations are using their analytics in very interesting ways. Without further ado, I'll just jump into these cases. The first one is from First one is from American Express. Everybody know American Express, major credit card company. This is from American Express in Australia. And for corporate accounts, so American Express has a lot of corporate clients, and they want to understand churn, meaning customer attrition. So a corporate client would, stop being a client of American Express. Now, the conventional wisdom. And this, I think the battery's dead. I don't know. It's off? I'm sorry. Okay, the conventional wisdom is that what they did before using analytics is to look at the enterprise data and look at if a customer's spend drops severely and recently, then they're going to attrite, meaning they'll stop being customers. It makes sense, right? So if you see, transaction records and suddenly a customer spends, the amount that the customer spends on average just drops suddenly and severely, a big drop and a sudden drop, then it's very likely that they're no longer going to become a customer. This makes sense. This we can do with just the enterprise data, but what's the problem with this kind of analysis?
It's only tell you the customer is...
It's too late. It's too late to do anything about it. Right? The timing of it is completely off. We know that with almost very high certainty that if we observe this kind of behavioral phenomenon, if we observe that a customer spend drops severely and recently, and they're going to churn, then it's too late to do anything about it. We want to be able to know before this happens so that the customer representatives can call them up and try to understand the situation, try to regain their trust, regain the business relationship, and help them continue the business relationship. But the current analytical tools or the current ways of analysis were not very satisfactory. And so a data analytics team within American Express developed using 18 months, it's a year and a half of historical transactions using 115 different variables. That's a lot of variables to put in a model. Okay? They were able to analyze the historical data to identify, a quarter of the accounts that were likely to attrite or no longer be customers within the next 4 months. Okay? So it's not after the fact. It's not after the fact that it's happened, but in the next 4 months, so we still have time to be able to do something about it. So these predictive models have been used to call up these customers, to regain their trust, redevelop the business relationship, and make sure that they don't, continue their the day-to-day business as usual, and then 4 months later they might be able to attrite. Okay, so this is very important. Because now we need to realize that some of the analytics that we do really has to be timely. Okay? We don't want to know what we already know. We don't want to know things that could be immensely useful, but that don't really help us because it's too late to do anything about it. Okay? So these kinds of models are actually helping companies like American Express really predict in the future what's going to happen and do something about it. They can intervene and do something because we know that these customers are likely to attract. Now, from this case, it's not discussed here, but one of the things is that once they had this model and they talked to the managers about this model, the managers weren't very happy. They were saying, well, I don't really believe it, right? And it's really, and they were asking, tell me what causes attrition, customer churn. But it's a very complex model. You have 115 variables that's working in very complex ways, right? But there's no simple answer. Okay, so there's a big kind of a chasm within the organization. Managers needing to understand what the predictive, or having more confidence about trusting these predictive models because they could be very accurate, and the organizational culture, the open-mindedness of the companies in being receptive to these kinds of conclusions that are drawn. Okay, so this is a challenge, and this case highlights this in some different aspects that I haven't highlighted here, but it highlights the human element, the receptiveness of organizations in actually using analytics. I'll get to that in a little bit in a different context as well. Next case. This is IBM is working with Beijing city government to fix its pollution crisis. As you know, Beijing has one of the world's worst pollution kind of situation right now. Okay, its pollution is just horrible. The kids going to school, a lot of times they can't go outdoors and do sports activities. Pollution level is horrible. So Beijing city government has contacted IBM to lead its kind of war on pollution, so they're working on this Green Horizon project where IBM is equipped to use big data, use Internet of Things, use weather modeling kind of technologies and supercomputing to really understand how the weather conditions, the meteorological kind of models actually tell us about when and where the pollutions are going to happen, and so to predict the different aspects about the pollution forecasting. What this does is it helps the city government and especially the power companies to predict the energy usage levels. Okay, because a lot of the pollution actually is a result of the use or misuse or overuse of energies, and that's causing the pollution. So if we better understand, if these companies have better ability to understand the weather models, the predictions about the weather, then they can they can allocate or predict the demand for their energy and calibrate their energy production levels such that they don't waste energy production. Okay, they don't produce energy that's going to waste and that's going to create pollution. So they have a better understanding of the overall kind of mechanism through which pollution happens, and they're trying to understand the environment, the weather environment, in such a way that they can help and intervene in reducing the pollution problems. Again, this is using large amounts of data, creating these linkages between very complex weather-related, physical phenomenon data with, using a lot of sensors to capture and better understand the physical environment, and using complicated models to be able to create predictions about future causes, future situations where pollution might be more prone. Okay, so this is an example where that highlights the fact that we can really do a lot of good, right, with analytics. Okay, we can solve very complex problems by being creative about what we need. Okay, now if you were just the Beijing city government, okay, now, and if you were to rely on only the data that you have, it would be very difficult to come up with this kind of ingenious solution. Okay, now how they come up with the solution, that's another lesson to be learned, but it's really about figuring out what is the objective we're trying to accomplish here, what is the data that we really need, or the knowledge that we need to solve that objective or solve that problem, and being creative about how to capture, how to create and capture the data that will help us solve the problem. Okay? That's kind of the soft element of data analytics that nobody teaches you. If you go to programs, you go to a master's program in business analytics, they will teach you a lot of statistical techniques. But the real intuition comes from, the real value comes from really coming up with these intuitive ideas about, here's the problem I want to solve, here's the data that I have, but really here's the data that I don't have, but what is the data that I could have that would really help to, create models, create like results that would help me solve the problems at hand. Okay, that's the most important part. The statistics, all the techniques, that's easy. We can train people to do that. But training people or having managers or analysts be knowledgeable of these opportunities, that's the $1 million question.
โอเคเมื่อกี้เขายกตัวอย่าง IBM ก่อนMX ก่อนนะครับที่ออสเตรเลียนะครับเขาใช้ predict data ที่สามารถที่จะบอกซะก่อนล่วงหน้าสักประมาณ4 เดือนนะครับว่าลูกค้าคนนี้จะยกเลิกบริการหรือเปล่านะครับก็คือเขายกตัวอย่างว่าจริงเขารู้แพทเทิร์นแหละถ้าหยุดใช้สักพักนึงเนี่ยจะเลิกแต่เขาบอกมันช้าเกินไปนะครับก็ตอนหลังเขามีการวิเคราะห์เพียงแต่วิเคราะห์ของเขาเนี่ยเขาบอกว่ามันยังเป็นกล่องดำอยู่ก็คือไม่รู้ว่ามาจากสาเหตุอะไรนะครับเพราะแฟกเตอร์มีเยอะก็เลยทำให้ผู้บริหารของ AMAX ก็ยังไม่ค่อยจะagree กันว่าจะต้องทำยังไงนะครับในเคสนั้นเดี๋ยวเขาบอกเขาจะเล่าอีกทีแล้วก็อีกตัวอย่างหนึ่งเขาเล่าให้ถึงเรื่องที่ปักกิ่งนะครับเรื่องการสู้กับ pollution นะครับก็คือพยายามจะคาดการณ์นะครับI not get the Beijing a little bit is they try to sort of turn on the power solar system, wind system to minimize the impact. Is that what is that? What is the real output? So they try to what allocation of
energy production.
Energy production, right? Okay. นะครับคือเขาพยายามที่จะพยากรณ์คืออันหนึ่งพยายามทำให้ pollution เข้าใจว่า air quality เนี่ยนะครับให้มันดีอย่างน้อยอยู่ระดับที่ไม่ใช่อันตรายนะครับด้วยการที่จะบอกว่าวันนี้จะผลิตไฟฟ้าด้วยพลังงานลมเท่าไหร่พลังงานโซล่าเท่าไหร่อาจจะมีพลังงานถ่านหินหรืออะไรก็ว่ากันไปนะครับแต่ว่าเพื่อทำให้อากาศเนี่ยมันอยู่ในระดับที่ต่ำนะครับอันนี้ professor เขาก็พูดว่าความสำคัญอ่ะมันไม่ใช่ว่าเอา data มาแต่ความสำคัญมันมากกว่าสถิติมันคือการเอา data ที่1มีอยู่แล้วและ2ต้องคิดต่อว่าแล้วที่ยังไม่มีคืออะไรหรืออาจจะต้องทำเพิ่มนะครับก็คือการทำโมเดลลิ่งคือทำตัวโมเดลนี่แหละแล้วสร้างขึ้นมาซึ่งต้องมารวมกับหลายสาขาอาชีพผู้เชี่ยวชาญต่างๆมาช่วยกันสร้างโมเดลที่จะ forecast เขาบอกอันนี้คือความสนุกของการทำโปรเจกต์อย่างพวก big data โอเค I talk about you have to bring the data that you have and you don't have try to create something that is a fun of doing the big data that you like.
Okay, thank you. Okay, next case is from Singapore in healthcare. Okay, now so far. So there's a couple cases here. One is from the Changi General Hospital, and it's probably the same, at least in the countries that I've been at. If you go to the emergency rooms, emergency departments, the wait time is horrendously long. You're in the emergency department. It's an emergency. There's blood gushing out or something. You're really sick. You went to the emergency department, but it takes way too long to see a doctor. Right? Then why would I go to see an emergency department? Anyway, so the problem is waiting times for patients at the emergency department was too long. Okay? And so what the analysts at Changi General Hospital did was they analyzed the data, the patient arrival data, 3 years worth of data on who were the patients coming to the ER, which days of the week, what times of the day they were coming in, what were the real acute cases, what were some of the less acute, but they actually come to the ER anyway kind of cases, and come up with some relationships or knowledge patterns about when people are most likely to come, what day of the week, what kinds of cases are likely to come. That creates knowledge about the demand for different kinds of doctors. Okay, so when you come into the emergency department, you would have broken legs, cold, fever, all these kinds of symptoms, but there is apparently some patterns to that occurrence. Now, if we know the demand for healthcare, meaning if you have a lot of broken legs coming in on Monday mornings from like kids playing soccer on Sundays or something, or Sunday afternoons, if we know the time at which these accidents occur, then we can reallocate the doctors or the timetable of the doctors such that there's a lot more orthopedic surgeons manning the ER department, the emergency department at that time, and so we can increase the throughput of the patients. By doing that, they were able to reduce the wait times just by creating some overlapping times between the physicians' kind of work shifts and reallocating the timetables of the physicians. Very simple things. They were able to enact a 24% reduction in waiting time, which is actually quite significant if you think about it. Okay, so by simply analyzing kind of the data on the patients, and identifying patterns in that, we can better understand the demand of the arrival cases and allocate the service production kind of systems such that we have increased the throughput. Okay, so this is a clear example, a very interesting example of how data analytics can be used, to improve healthcare in Changi General Hospital. The next case is from Alexandra Health Systems, and what they want to do is use predictive analytics for preventive care. So one of the interesting thing about hospitals or healthcare is that what we really want is people to not come to hospitals. That's the goal. We don't want to have people come and fix them. We want them to not be healthy and not come to the hospitals. That's the irony of healthcare. Now, so the challenge here, the predictive analytics for or preventive care or predictive analytics is extremely difficult. Why would that be the case? For healthcare, predictive analytics for healthcare. Preventive care is extremely difficult.
Data of the patients.
Now, think about patients, okay? Medical records of, so it's healthcare data. When does healthcare data get created? When does the data, actually the observations get created?
When they come to see the doctor.
When they go to see a doctor, right? Which is not very frequently. So if we have a doctor monitoring us 24/7, then we would have a lot of data. But we only see the patients at their worst when they come to the doctor, see the doctor. And so these are the kind of the extreme or exaggerated kind of cases. We don't know their actual kind of health biosignals and whatnot, but we only see these biased cases and quite intermittently, not very frequently. And so we want to make inferences about a patient's overall kind of health process, but we only have limited observations that are not the normal observations, but there are the skewed observations, the biased observations. And so creating the normal, kind of recreating the normal model is actually very, very difficult. Okay? Now, so here, these are some initial kind of initiatives where through a survey of the general population, and so using surveys, they can actually get into, they're trying to get into creating some predictions or models about when, in a macro scale, when people are likely to develop different kinds of complications, mostly aging related, so diabetes, heart disease, these kinds of conditions, so that we have a better understanding, a macro level understanding of the demand for healthcare, which can be fed back into like the educational system in terms of what kinds of courses or what specialties we want to train, and so that it creates a better market, a more even market for the healthcare demand and supply. Okay, so it's done at more of this kind of national level. So that's the goal. That's the goal. It's still a work in progress. Now, I just wanted to mention that preventive care or predictive analytics for clinical data is still very difficult. Still to this day, a lot of the analytics that happens is only with operations data. Okay, but we really want to get into the clinical analytics We actually, at the University, National University of Singapore, within our department, we actually have a center for healthcare informatics where a lot of our colleagues are actually working on clinical data mining and clinical data analytics, and I'll share some of that in a little bit. Okay. Okay. Now, this is probably the most interesting case that I've encountered so far. Okay, I've mentioned Didi several times during this presentation, so I mentioned that Didi is a ride-hailing company in China, like Grab. Okay, actually they've actually invested a lot of money into Grab, so they have partnerships with Grab. So this is Didi. They have almost 96% market share within China. They've actually just captured the market. They just obliterated everybody else. Okay, now there's a lot of different things that Didi is doing. Okay, using analytics. This is one example. They have these real-time heat maps. They can, based on people's hailing behavior. So I have an app and I want a cab or a car from point A to point B. I can understand. So Didi has a view of where there's demand for cars and where the cars are, right? Because they have the navigation data of the cars that the Didi employs. Okay, the drivers of Didi, for Didi. Okay, so we know, so the red ones, I think, are the ones where there's over demand for cars. So there's a lot more passengers trying to get cars, whereas the green ones are where there's oversupply of cars. The yellow ones are with it's equal, where it's, there's kind of a level demand and supply. Okay, so if you're Didi, how do you use this? Now, first, why do we need to use this? What's the problem from having a lot of reds and greens on this picture?
A lot of reds mean customers there.
Yeah. So if you have a lot of reds, what does that mean? If you have a lot of reds, we have a lot of waiting customers. Customers want to go from A to B, and they want to go to B as fast as possible. The more I wait, the lower the quality of service. So if I'm Didi and quality of service quality is one of the main factors in customer kind of loyalty, then I really want to see a lot more orange. Every place here be yellow, right? If I have too much green, that's not a good thing either. We have unsatisfied drivers, right? Drivers cannot get enough passengers, right? So in order to satisfy both the supply and demand side of their supply chain, the drivers and the customers, not just one side, we want to redirect traffic in such a way that the oversupply and the overdemand does not happen. This is very ingenious, right? So it creates happy drivers as well as happy customers. Happy everybody increases the business for Didi. So having this kind of knowledge is very important. Okay. Now this can be done with only data that they have internally, right? They know who's hailing, who's requesting cars, and we know which cars are currently active on their platform. So this is possible, and so this can be done internally within Didi without any additional effort. Okay. Now there are other aspects of Didi or ride-hailing that is actually not quite so possible with the data that they have. Okay, so these are some of the additional things that Didi's are trying to do. Okay, one of the things that they have done, an additional thing that they have done, is to use the historical ride-hailing and so when people hail, when the cars accept, how long it takes for the cars to get there, how long it takes for the cars to get to the destination, all this data to create forecasting models about driver the hailing demand. Okay. Now here, ingeniously, I don't know the details of the forecasting model, but they created very accurate models that can forecast demand 15 minutes in advance with 85% accuracy. Okay. So what that means is 15 minutes before somebody actually hails a car, I know which region might have somebody that's going to hail for a car. If we know that, then we have a lot more degrees of freedom about dispatching cars even without a hail. So it's not a realized demand, but with a predicted potential demand, I can put a car in that vicinity such that the wait time of that consumer, that ride hailer, can be minimized or reduced. Right? Okay? Is 15 minutes enough? It's already good. But if we had 30-minute lead time into the demand, there's a lot more possibilities in terms of what you could do. Right? This is like understanding American Express attrition 4 months in advance. There's time to do something. Right? So having real-time like supply and demand data for the passengers, that's one thing. Right? We know, when the customer spend for credit card goes down dramatically, and recently they're going to attrite, it's the same thing. We have over demand here. We can try to reduce the wait time then and there, but there's only so much that you can do when you don't have that much time, flexibility of time ahead of that event. If you can predict an event 15 minutes in advance or 30 minutes in advance, then there's a lot more that you can do. You can actually intervene to do something. Okay? And so these are some of the challenges that companies like Didi are facing. The next really interesting aspect of the Didi case is that they're sharing data with the city government. So there's some experiments with the city governments. So in Shenzhen, for example, they collaborate with the city government, the police, and they can actually, they've acquired access to manipulate the traffic lights for a number of different intersections. Okay? Because they know the traffic flow within the cities, they can, by turning on and off the traffic lights, they can actually redirect traffic to reduce the traffic congestions. Okay? So even with a limited number of traffic kind of light access, they've been able to create 10 to 20% reduction in actual traffic journeys. So the traffic duration has been reduced 10 to 20%. So a trip that would take 20 minutes would now take 16 to 18 minutes instead of 20 minutes. Okay? Again, that increases the satisfaction of their customers. It increases the city's kind of satisfaction with the problems the traffic congestion problems that they have. So it creates a win-win situation, right? Another kind of collaboration engagement is with again Shenzhen. Didi has a kind of a service that they call Daijia. Okay, this is the designated driver service. So instead of having a car, somebody else's car, come and pick you up and take you somewhere, they have a driver come to you and drive your car to your home. Okay, so if you're driving and you go somewhere and you had a little too much to drink, too much alcohol to drink, and you can't really drive home, then you would call the Daijia service. They would have a driver come to you. They would drive your car to your home so that you don't have to pay parking fees. You have your car at your home safely, and you can start the next day fresh. Okay, so what Didi is actually doing is sharing data about the Daijia demand. Okay, we share data. They share data about Daijia demand. Which areas of the city actually have Daijia demand, so that the police can dispatch their officers there and catch drunk drivers. Okay, so those that are using Daijia are actually safe because they have a driver that drives them home. But if people are using Daijia in that district, then there's likely other people who are in a similar situation who are not using the service. And so we can redirect or direct the police's attention to those areas where that kind of situation is more likely to occur. Okay, so again, this helps the police, catch drunk drivers, and that's supposedly a good thing for the city, But how does it help Daijia or Didi? Again, the important thing to realize here is they don't do this as a public service, right? They're not doing it as a national service or a public service to make the city safe. There has to be the company's incentive and profit maximizing incentive in mind. if this happens and the police are better at capturing drunk drivers, it increases the demand for digest services. Right? Because we've created an environment where, the drunk drivers are more likely, are more incentivized to call a designated driver. Right? And so you really have to think about how to kind of interpret or make sense of the data and how to use it in ingenious ways where here they're sharing the data, they're giving the data in order to create new services or new demand for its services. Okay? Okay. In the previous, so that's just sharing their own data. With the previous case of the traffic lights or the city congestion, what they're doing is they actually are sharing the data both ways. Okay, so they have data on the city's traffic congestion that's maintained by the kind of the police and the traffic management, but they are gaining access to that data. So they requested access to that data, and they share their own data with the police, so that the sum of the data, okay, the aggregate sum of the data is more complete and paints a better picture. Okay, so Didi has algorithms, better algorithms than the police. Okay, so they can create, they know when and where to turn the traffic lights green or red better than the police, so that it creates better outcomes. But they don't really know all of the data about the traffic congestions. Because, as I mentioned earlier, although they have 96% market share, they only have on the roads, only about 10% of the cars on the roads are their cars, right? And so they don't have a really good picture about the actual traffic congestion situation within the roads, on the roads, right? So if they can contribute their algorithms to the city, but they get in return the actual congestion data. And if I can couple the actual city congestion data, the traffic data, with my own supply and demand data, I can provide better dispatching services, or better dispatching performance. Okay, so this is again to highlight that data, a lot of the data that we need in order to create better services or better, make better decisions, don't exist within the company, right? Only a few handful of privileged companies that have tremendous reach, global reach, like Facebook, Google, only these companies have really accurate or very widespread, like reliable data about the population. Most companies, even companies this successful, like Didi, who has 96% market share, does not, because ride-hailing is only 10% of transportation within the overall domain of transportation. Okay, so if I have data on another initiative that Didi is doing is collaborating with public transportation services like buses and trains to know the travel times of the arrival times and departure times of the buses, so that they know where the customers are actually, when the customers actually need to use their ride-hailing services. Because most of the time, customers, when they hail a cab or a car to go from A to B, it's not actually to get to B. I want to get to B so that I can take something else to get to C. Right? I want to go to B, which may be a train station, which may be a bus station, right? Or I may be going from getting off the bus or getting off the train so that the last 5 minutes, the last mile to get home could be a Didi ride hailing services. So we want to better understand the customer's overall transportation journey, but Didi only looks at or only has information about a portion of it most of the time. If we understand the full journey, then it's much better. So Didi is actually collaborating with, getting access, sharing its data with the public transportation services, so that they can better create their timetables for the public, like buses and trains, but also better understand the customers' overall journeys. They're also collaborating with companies like Ofo, which is a bike sharing platform, to understand, because sometimes you get off the car and then you take the bike to go home in the last mile, to better understand the overall customer journey. So these are quests for gaining access to data for a more complete picture of your stakeholders. Okay, it's not just, I'm not a ride-hailing company. I'm not just going from A to B, but I am contributing or supporting the overall journey, customers' kind of transportation journey, and my part could be very little. But if I understand the overall context, then I have much better information about how to maximize the quality of the service for that little segment that I have. Okay, that's another insight. Now, Didi's also has some interesting initiatives to use the driver's GPS data to increase road safety. So, at any point in time, Didi is collecting using the GPS data to actually understand the speeds at which you're doing, the speeds at which you're driving. Okay, so from this you can know, whether or not you're speeding, you're going too slow, all these, and you understand traffic conditions. So it provides that kind of data, but it's used to enhance the road safety so that it increases the service. The customers, the riders actually value road service very much. Another thing that they use is this reinforcement learning, where Didi is using its the actual, it's not just using its data to offer its services, meaning you have the ride hailing and you make the car drive from point A to point B. So when you take a Grab, usually you have this expected time duration, right? So it tells you you're going to take 20 minutes. That's, again, the accuracy of that is kind of off. It's not that accurate, but it can be used to recreate or refine your own services. So I'm getting a little convoluted here, but as an example, when you have a lot of routes or a lot of cars driving from point A to point B, where we've estimated that it might take 20 minutes to get there. If you see that many cars have suddenly they're going from point A to point B, but they're taking 15 minutes instead of 20 minutes. A much shorter time than the predicted arrival time. What does that tell you? Or if it's taking 30 minutes instead of 20 minutes, how do you interpret that data? Because these are deviations from expectations. This is what I thought would happen, and that's why I dispatched the service that way. But the actual behavior, the actual occurrence in the real world deviates from that prediction. That data is also immensely useful. So if it takes 30 minutes to get there, to get to the destination when we predicted 20 minutes, and it's happening frequently enough to be a pattern, how do we interpret this?
Yeah.
There must be an accident, there might be construction, there might be some event that I haven't predicted, that a change in the environment that impacts my service quality that I can't, that's happened that I haven't put in my model, right? The quicker I capture that kind of insight, the quicker I can recalibrate my model such that the next customer goes through, I give him a different route on the GPS such that we don't replicate the same problem. Because if a customer is expecting a 20-minute ride and gets a 30-minute ride, they'll be unhappy. Right? So you can use that information to improve your services. Now, if it takes 15 minutes instead of 30 minutes, what does that tell you? The driver was speeding, maybe? But if it's not that, if that hypothesis is refuted, if you don't, if you discredit that hypothesis through analytics, of course, what does that tell you? There might be a new road.
Okay.
Didi is not in the business of doing maps, right? Didi is not in the or urban planning, right? I don't, they might create a new road, or a new road might have opened from this part of the city, but Didi cannot keep track of all of that. Now again, one way to get that data is through collaboration with the city urban development, departments, to get all of the updated, the road opening and closure data, and incorporating that into their own algorithms and systems. Or another way to do this is to use this kind of insights about driver delays or advanced arrivals to predict, to capture whether or not a new road has actually opened, right? So using your own data, instead of collaborating with others, you can actually gain access or create insights about your own kind of business operations. And that's kind of the key or the tension that you really need to think about, okay? There's a lot of new insights that you can generate with your own internal operations, right? And there are situations where you need data that could help you better understand that you wouldn't otherwise be able to do with ingenious kind of data analytics, okay? So DD case shows a lot of different kind of aspects of how analytics is helping to improve its services, products and services, how its quest for better interpretation is leading to different kinds of initiatives. One is better interpretation of, or more smarter interpretation of their own data to improve its services, or its quest to collaborate with others that might have critical data that could help to improve its services. But the key is we want to create a win-win situation where we're giving the collaborator something, but in return we're also gaining something that helps us do something.
Can I say that did he use big data for day-to-day operation, basically an hour operation, right? ก็คือความจริงเขาอธิบายเยอะมากเลยนะครับแต่ว่าถ้าจะพูดให้มันสั้นๆก็คือว่าเขาใช้ข้อมูลถูกไหมเอามาวิเคราะห์เอามาใช้ให้คำแนะนำคนขับจริงๆนะครับหมายถึงว่าเป็นรายชั่วโมงราย15นาทีเขาเลยใช่ไหมที่เขาจะบอกว่าเนี่ยเดี๋ยวจะมีลูกค้าอยู่แถวนี้เยอะนะรถใครไหนอยู่ใกล้ๆช่วยย้ายไปแอเรียนิดหน่อยต้องการรถอีก5-6 คันนะครับซึ่งเขาบอกว่าเขา predict ได้15นาทีล่วงหน้านี่หมาย15นาทีล่วงหน้านี่แปลว่าอะไรแปลว่าอาจจะลดการรอคอยของลูกค้าลงเยอะเลยคือประมาณว่าเรียกกดปุ๊บ5นาทีมาประมาณนั้นนะครับซึ่งก็มีประโยชน์มากแล้วเขาก็ยังพูดถึงหลายอย่างใช่ไหมครับในเรื่องของแชร์ข้อมูลกับซิตี้นะครับแล้วตัวเขาก็ได้ข้อมูลด้วยซิตี้ก็ได้ด้วยนะครับในการเรื่องทราฟฟิกต่างๆนะครับที่น่าสนใจของเขาก็คือเขามีช่วยแจ้งตำรวจว่าผมเดาว่ามันเห็นคนอื่นขับรถอ่ะถ้าคนไหนสายปุ๊บก็บอกกทตำรวจก็ไปจับทางอ้อมก็คืออะไรวันหลังคนกินเหล้าก็จะอะไรจะเรียกใช้บริการเขาเพราะก็มีบริการอะไรนะไดเจียอะไรเนี่ยนะครับคือเรียกมาแทนจะได้ไม่ต้องถูกจับนะครับไอเดียมันก็ดีเนาะเรียกตำรวจมาจับคนอื่นนะแล้วก็จะได้มาใช้บริการนะครับก็โอเคนะครับแล้วก็ยังใช้อีกหลายอย่างนะครับใช้หลายอย่างในเรื่องเขาบอกว่าเส้นทางการปรับปรุงเส้นทางนะครับข้อมูลที่มันมากกว่าสถิติเขาก็แปลผลหนึ่งน้อยกว่าสถิติก็แปลผลหนึ่งเขาบอกว่าถ้าเกิดเส้นทางนี้ปกติใช้เวลา10นาทีแต่ถ้าเกิดอีกคันหนึ่งโผล่ไปมันใช้เวลา20นาทีเนี่ยเขาต้องวอร์นิ่งคันอื่นละมันคงจะเกิดปัญหาอะไรเวลาพิจารณาเราตอนที่ไปรับไปอะไรก็ว่ากันไปอีกทีนะครับเพราะฉะนั้นตรงนี้ผมก็แค่จะสรุปสั้นๆว่าคือเขาใช้ Big Data ในเชิง Operation แหละที่ผ่านมาเราจะเห็นว่า Big Data ในเชิง Strategy ในเชิง Policy ถูกไหมจะต้องทำอะไรตรงนี้นะครับแต่นี่เราพูดถึงแบบข้อมูลประมาณ10นาที15นาทีที่ต้องมีการส่งข่าวสารกันตลอดเวลานะครับในเชิง Operation นะครับและทำให้รายได้นะครับก็อย่างที่เรียนได้ทราบแล้วเนี่ยคือการแข่งขันของแท็กซี่ในอนาคตเนาะ เหนื่อยแทนประมาณนั้นนะครับโอเค
So I realize the time has already passed quite a bit. So the insights, as I mentioned, data helps to improve services and create new services. We can have a company may have a lot of data, but never all of the data, which requires collaboration with others. So you have to think about what data do we have, and what data do we actually need. That's the critical. The million-dollar question that you need to ask is what data do we actually need in order to improve our services or create new services. Okay. Now I just wanted to quickly go over, I think very quickly, some exciting research that we're doing at NUS School of Computing, given this opportunity. So we use big data analytics and in doing kind of academic research, and also some translational research. So we work with companies and helping them create new algorithms for a number of different kind of contexts. So some of the research that we're doing, we're really trying to understand. We have some colleagues that really try to understand how people get information. What news do people read? What news are more likely to share? Does the sentiment of the news headlines matter in sharing or reading of the news, or does the sentiment of the articles, of the article body, not the headline, actually matter? And so we want to understand. Here we have we have some colleagues who want to understand people's information diet. Okay, what are the different things that are influencing the information diet? This has a lot of implications for how people get educated or become knowledgeable about different events that occur in the world. The political kind of not aspiration, the political tendencies of the citizens. Whether or not we'll see more of an echo chamber effect. We only read or share news and create these more tight-knit networks that only talk to each other versus becoming more and more diverse. So this has a lot, some bigger implications about overall citizens' overall knowledge about current affairs and things like that. So that's one project. We're actually collaborating with Singapore's SPH, Singapore Holdings, and Straits Times newspaper to actually get the data, get the people's the web server logs for how people actually use the data. We have information from Twitter and Facebook that we can connect back to the readership. So we've been doing that. The next is this is one of the projects that I've been working on, looking at crowdfunding research. Okay, crowdfunding, the phenomenon where you have sites like Kickstarter, Kiva, Indiegogo, where individual entrepreneurs would post a project, a campaign for fundraising, and the crowd would fund the projects. Now, this is an interesting domain, especially for a website like Kickstarter. I hope people are familiar with the concept or notion of crowdfunding and Kickstarter, where from a national or global economic development perspective, crowdfunding is a very good platform for nurturing entrepreneurs, or not training, but creating an environment where they can learn to become successful, and it's spurring entrepreneurship as a means of kind of economic production. Right? We want to see more of that. Right? We want to see people becoming more entrepreneurial, creating startups, creating products, and actually succeed at doing that. And so this gives us an interesting data set or an interesting context where we can understand the development trajectory or the learning trajectory of entrepreneurs. Right? Entrepreneurs, again, it's a very difficult area of study because we don't have a lot of data about entrepreneurs. And there's always a survival bias where we can observe when we want to study entrepreneurs, we go after successful existing entrepreneurs, and those, when we ask entrepreneurs, when we survey or when we do interviews with entrepreneurs, it's only those that have been successful, that have lasted, that actually respond. So we only see the success cases. We don't see the failure cases. Crowdfunding gives us a context where we see everything. We leave traces of data about all the entrepreneurs' behaviors, so we know what kinds of past experiences, whether successful ones or failure ones that actually lead to more successful future ones, whether or not how they managed the previous campaigns actually influence the success probabilities. And so we've been using the data whole history of Kickstarter to understand the entrepreneurial trajectories or the learning trajectories of entrepreneurs. So this gives us some insights that we were previously unavailable because of the lack of access to the right entrepreneurial groups. Another project is actually looking at credit scoring. So when we go into many different regions, especially in Southeast Asia, there's a lot of people who are unbankable, outside of the banking system, right? Especially in rural parts of the world where, although they're using smartphones, they're using social media, they don't have access to banks because of lack of credit history, right? They don't have a credit score. So we have a team of colleagues that create algorithms and models to do credit rating or assess the credit worthiness of people using their social network behaviors. Okay, so if you're on Facebook, that's a social network, and you want to borrow money, I can look at your friends to try to figure out if because of my friends, if I'm credit worthy. Okay, so one of my colleagues is actually working with a lending company to create algorithms to perfect, to create better credit worthiness, credit scoring systems to create better risk models. Okay, and so this actually helps in economic development for these countries or where these kind of people need access to capital funds. Okay, I have a colleague who's looking at labor economics and mobility of workforce, especially in terms of engineers and scientists. Now, one of the things that people are interested in is developing these kinds of, how do we recreate a Silicon Valley, right? How do we bring people? How do we understand the mobility of scientists and engineers? Are there the backgrounds? Is it the nature? Is it nurture? All these things, but it's very difficult to track people, especially scientists and engineers. Okay, previously, because of their activities, a lot of the prior studies used patent data or patent filing data to track people's mobility within their careers. Now, one of the things that my colleague is doing is using LinkedIn data or data from LinkedIn to actually track people's mobility, and it's providing a much more accurate view of the workers' mobility, especially at least within the scientists and the engineer tracks. It's creating a very vivid and very accurate view of worker mobility in these markets. So this kind of data, actually it's at a very initial early stages, can provide a lot of interesting insights into labor economics. Okay, I think finally we have, as I mentioned earlier, we have a team that's actually looking at predictive models for clinical data analytics. One of the interesting things here is that, as you can see in this picture, there's a lot of sensors, right? You have things that measure your, and we have intermittent kind of capture of data, like your blood pressure, all these vital signs. Some of it is done in real time. Another source of very important data are the nursing notes. The nurse comes in, checks your vitals and writes some notes, but it's unstructured text. And so the clinical data available is very complex and are at different times. So some are done in real time. Some are done whenever a nurse visits or when it's checked. Some are done intermittently. And so just the compilation and the transformation of the data for analysis is really difficult. And also the varied nature of the data, the structured data, the sensing data, real-time sensing data, the occasional observation data, all of this is very complex. And so I have some colleagues who are working with hospitals and actual these kinds of data sets to create preventive care models where we can predict ahead of time, at least predict whether or not a patient is prone to getting a complication during their stay within the hospital. Okay, so again, this is a very important area of research where at least when you're at the hospital, if we can predict complications early on, then we can actually dispatch people or create a better environment where these people are monitored more carefully, such that if a complication were to occur, then we can react much more quickly. But if we're reactive, and if only react when a complication happens, then it's much more the quality of the remedial action might not be as high. Okay, so this helps to save lives. Okay, I think that's it. So as a recap, what I want to emphasize in this presentation is that the techniques about data analytics, and that's what most people hear when we talk about analytics. When you just discuss data analytics, everybody talks about R, Python, classification, AI. They talk about the terminology or the lingo, the techniques, statistical techniques, the artificial intelligence techniques. That's not that important. Okay? The objective of analytics is most important. Understanding of the domain is most important. Okay? What you want to do with it. What is that you want to do, that's most important. The second takeaway from those cases and the presentation is that data can come from anywhere, right? Data could be already existing within your processes, your operations, but you can also create data by, for example, embedding cameras to cars so that you know the lane changing behaviors. And you can gain access to data through collaborations. And so this, you really need to know what you need so that you can think about how to access or create access to that kind of data. Okay. The third is that each organization may only have limited view of the data that you need. Okay. The scope of the data, although it could be a lot of data, it still doesn't paint the whole picture. And so you really need to be mindful and open to the idea of collaborating with your competitors even so that you can create better services. Yeah, Didi is easy because Didi owns the market share. It has all the ride-hailing data. But if you're in a situation like in the US where Uber, Lyft have kind of equal market share, then they only see small slices with only their internal data, right? But the sum of the data could enhance both of their services. And so the overall customer welfare will be increased, right? And creates value for their own, for each, both Uber and Lyft's services, but they don't want to do it because they're competitors. And so they have to see beyond that, okay? I'm going to, yeah.
โอเคเมื่อกี้เขาก็ยกตัวอย่างให้ดูเยอะเลยนะครับถ้าจะดูก็คือพูดง่ายๆถ้าบอกจะเป็น Thailand 4.0 เนี่ยนะใช่ไหมครับก็คือเราต้องแอปพลิเคชันของBig Data เนี่ยคงปฏิเสธไม่ได้นะครับมันจะมีประโยชน์หลายอย่างนะครับข้อสังเกตให้ดูนิดนึงนะครับว่ามันจะต้องพยายามที่ต้องมีคำถามขึ้นมาก่อนนะมีความสงสัยแล้วจะตอบยังไงเป็นคำถามซึ่งนำไปสู่การแก้ไขปัญหานะครับโอเคเสร็จแล้วเขาก็อธิบายตรงนี้ใช่ไหมครับว่าเนี่ยเขาถึงบอก Objective ของ Data เนี่ยคือเป้าหมายของมันสำคัญมากสำคัญคือต้องรู้ว่าเอาไปทำอะไรได้ข้อมูลมานี้จะไปทำอะไรขึ้นมานะครับเพราะฉะนั้นต้องมีความเข้าใจนะครับเพราะจริงๆแล้วไม่ใช่เรื่อง Technical Background นะครับเป็นเรื่องของการตั้งคำถามประสบการณ์ที่อยู่ในฟิลด์นะครับว่าเป็นยังไงนะครับแล้วที่สำคัญเขาก็บอกว่า Data เป็นไงมาได้จากหลายอย่างนะคือความหมายก็คือจริงๆแล้วคือ Big Data ต้องมาจากหลายแห่งไม่ใช่ตัวเราอย่างเดียวนะครับตัวแวดล้อมต่างๆถ้าเป็น Public Domain พวกโซเชียลมีเดียต่างๆและอย่างอื่นนะครับแล้วก็ที่สำคัญที่สุดเขาพยายามจะบอกว่าอะไรในยุคอะไรนะ Digital Economy เนี่ยถ้าเราไม่แชร์ข้อมูลกันเนี่ย potential มันจะหายไปเยอะเลยนะครับซึ่งก็สอดคล้องกับที่คุณเบิร์ดแนะนำไว้ใช่ไหม Open Data ที่ออกคำให้ต่างๆที่ต้องมีนะครับว่าไม่งั้นเนี่ยมันก็จะไปต่อยอดไม่ได้แหละนะว่าง่ายแล้วประสิทธิภาพเราก็จะไม่ได้ผลอย่างที่เราจะต้องไปนะครับอันนี้ก็จะเป็นไอเดียในการเอาไปใช้ Big Data โอเค
Okay, so I just have one last kind of topic. I think we can go through it very quickly. It's really about, now that we understand the importance of data analytics and big data analytics, what are the capabilities and how do we develop them? So the main takeaway is that it's not about the technology, it's not about the technique, it's about the objective, it's about the thing. The more important factors are the human element, okay, the problem solving, the intuition, the kind of creativity that goes into knowing how to piece together my data requirements with my service design kind of requirements. The organizational processes are very important, and culture is very important. Okay, so these are more important in creating an environment within your organization to make data analytics a successful component for your organization. Now, if you think about the field itself, data analytics is a multidisciplinary field that requires both technical knowledge. We can't really do without the technical knowledge. We need knowledge of statistics, and we need knowledge of the domain. And so this social science is actually a big domain, right? And it could be the physical sciences as well. It could be like weather modeling and things like that. And so it's very difficult to train people in this area. Very difficult, right? You need knowledge of, before you would be either a computer scientist, you could either a statistician, or you could be like an economist or a sociologist, but you can't have all three, right? So in order to be good at all three, it's very, very difficult, right? So at the National University of Singapore, we actually have a business analytics business analytics degree program within the School of Computing, where we're focusing more on the computer science and the social science aspects of the capabilities. We also have within the School of Science a data science and analytics program, which is focusing more on the statistics, mainly on the statistics and a little bit on the computer science aspects of data analytics. Okay, so different units within campus are actually focused on different things. So it's a very difficult process. I don't know how the universities in Thailand are doing with respect to data analytics, but I think we have some benchmark models that I think we can discuss if the universities here are eager to do that. Okay, now I think I'll end it at this. I had an activity kind of discussion, but I think we went through most of the things. If you have time, I want you to think about this. Okay, when you go back, you think about what's the mission, what knowledge would help you achieve this mission most effectively, what data that you currently don't have would allow you to answer these questions, and saying what are the challenges that you face in enabling this process. If you have answers to these questions, I think you're on track. Okay? You can develop very ingenious, very creative solutions to that will help propel your organization forward in meeting the mission of your organization. So I'll end it at that. If you have any questions, please feel free to engage me during or after the talk. Thank you.
ครับมีใครมีคำถามไหมครับมีใครมีคำถามไหมครับนะครับ so I think they are a little bit overwhelmed but it's okay. I mean I think he's pointed out very good, but I like the most is like, okay, you have computer science and then you need a behavioral science. I think it's become more important because in reality คือต้องบอกงี้ว่าผมอยู่สาย supply chain เนี่ยเราจะบอกว่าในอนาคตที่มันจะมาเนี่ยคือสิ่งที่ยากที่สุดก็คือการคาดเดาลูกค้าพยายามที่จะคาดเดาลูกค้าแต่ว่างานวิจัยก็จะมาตรงนี้เยอะ I say that I'm in supply chain area. I know that right now the most research is focused on how to predict the demand, and then behavior is the key thing, and which is we don't know. Well, we need to have other people to come in and help, and it turned out to be social side, NGO. They are great. They are great at those type of things. So I probably conclude in here that working in big data environments require teamwork. And we have a team of many hypotheses to test and run or something like that. โอเคงั้นก็ขอเสียงตบมือให้กับวิทยากรหน่อยครับผมนะครับแล้วก็ Singapore is very close by, so you can contact him for executive program if you want to. Yeah.
I would like to know that.
Thank you very much, Dr. Jungpil. This was very interesting presentation. I would just like to also mention that if there is some initiative, if you want to personally take an initiative in your organization and you need support from data scientists, so I had made a mention of a platform called Kaggle, Kaggle. So an international competition can be launched on Kaggle. There are other platforms like Crowd AI. That's one more platform. There's another platform called Crowd Analytics. So we will put these, we'll provide you the hyperlinks so that you have these references with you. But there is an opportunity to collaborate internationally on some problems that you would like to crack using data analytics. That's one. And secondly, of course, it's important that you also look at Thailand. Universities like Kasetsat or Chula, other universities which have the capability on data analytics could also be leveraged for doing stuff which is relevant to your organization. So I just wanted to leave that thought with you before we call it a day today. So tomorrow morning we will start maybe half an hour. We will give from 9 to 9:30 so that you can complete your presentations and hand it over to us as a PowerPoint. And then we will have a session in the afternoon where you will be presenting on those presentations. So we will start the session on cybersecurity at 9:30 instead of 9. Yeah, so that we have all the presentations with us, and then we can have the afternoon session in a more structured way. Yeah. Thank you. No, I'm just giving them time so that they can give us. You can hand over after lunchtime, no problem, but you have at least a little time because we are running through a lot of material in a short period. So we need to give you at least some time so that you can, bring it up to speed. Thank you very much.